Good afternoon, everyone. Welcome to the class, sir. Right. We are entering into one more important topic. One more important topic from combinational circuits, which is we say it is MUX. multiplexer, which is a mux. What is its operation and how we are getting questions? Mostly we have been getting 2 marks question only from multiplexer. Most of the times we have been getting question. Let us see what is exactly multiplexer and how we need to understand what we need to understand about multiplexer. Let us see one by one. So multiplexer, which is multiplexing data from multiple inputs onto single output line. Once again, multiplexer is multiplexing data from multiple inputs onto single output line. When we have multiple inputs, the data from multiple inputs should be multiplexed onto single output line. There is nothing but a many to one conversion. We can say it is a many to one conversion. So if I say I naught, I1, so and so, let me say that I to power n minus 1. 0, it is started to power n minus 1. So it is to power n inputs. And here we have one output. In short, we name it as mux. What is its function is, it is multiplexing data from all these onto single output line. How it can multiplex? What do you mean by this multiplexing? Let us see one by one. So if I say one output y, at given instant of time, one input data will be selected on output line. So at given instant of time, only one input data will be selected on output line. So which input data will be selected on output line is decided by select lines combination. The vector on select lines is deciding which input data will be transferred to the output line. Once again, so only one will be selected on output line. Even though we have multiple, so it is selecting on output line, it is selecting only one input data. Which input data will be selected on output line decided by these n select lines, selection lines, or which are deciding which one should be selected on output line. That is select lines and input lines and output lines. So multiplexing data from multiple inputs onto single output line, or at given instant of time, only one input data will be selected on output line. Which input data will be selected on output line decided by selecting lines. Another way we can say about this is it is switch or controlled switch. What we can say? Controlled switch. What is it here? One output line will be connected to one of these 2 power n input lines. This one output line will be connected to one of these 2 power n input lines. But which input line will be connected to the output line also decided by control signals. These are control signals. These control signals have been deciding which these control signals are deciding which input line will be connected to the output line. At given instant of time, only one input will be connected to the output line based on control signal. So it is a switch which is connecting one output line to multiple input line. But at given instant of time, only one input will be connected to the output line. Which input is that? Decided by these control signals. These are control signals. And also we can see where it can be used. A simple example we can use. Here we have only one transmission line. Understand correctly? Here we have only one transmission line. We have multiple transmitters. Multiple transmitters are competing to transmit the data over single transmission line. Over single transmission line. But at given instant of time, only one transmitter can transmit the data. What is it here? At given instant of time, only one transmitter can transmit the data. Which transmitter is that? Which transmitter is that? Decided by, again, select lines or control signals. Once again, we have only one transmission line. 2 power n transmitters are competing to transmit the data. At given instant of time, only one transmitter can transmit the data. Which transmitter is that? Decided by these control signals or select lines. Once again, what is its functionality? Multiplexer is a simple statement is a multiplexing data from multiple inputs onto single output line. And also it can be named as controlled switch. The reason is one output line will be connected to one of these 2 power n input lines. One output line will be connected to one of these 2 power n input lines. Based on this n select lines are controlled signals. So only one input line will be connected to the output line. Which input line will be connected to the output line is also decided by this control signal. That is the reason it is called a controlled switch. Also, what we said here, we have one transmission line. 2 power n transmitters are competing to transmit the data. So, which transmitter has to transmit the data over this transmission line is also decided by select lines or control signals. That is at transmission end. At receiver end, once again, we can have here one to 2 power n, one to many, which is named as a demux. Which is named as a demux. One input data is available, and here we have a 2 power n outputs. Once again, input data will be transferred to one of these based on n select lines or control signals. N select lines or control signals. Data available on single input line will be transferred to one of these 2 power n output lines based on n select lines. Based on n select lines. So I will be transferred to one of these. Which one is that? Decided by again n select line. Again, we can name it as a control switch from one input to multiple output. Which output line will be connected to the input line decided by again control signal. So again, one to many control switch. Many to one control switch. One to many control switch. Also, here, if 2 power n receivers are waiting for data, only one receiver can receive input data. So, which a receiver is that decided by these n select lines. So, 2 power n receivers are waiting for data. Which a receiver is going to receive the data decided by n select lines or control signals. So, at transmitter end, at receiver end, here multiplexing, here demultiplexing. And one more important observation is here we have parallel data. Here we have parallel data will be serialized. On this transmission line, it will be serialized. Now, here serial data is available, will be parallelized. Multiplexer is converting parallel data into serial, and demultiplexer is converting serial data into parallel. Serial data into parallel. So, multiplexer and demultiplexer. Multiplexer is serializing, demultiplexer is parallelizing. So, parallel to serial conversion, serial to parallel conversion. Multiplexer and demultiplexer. Right? That is a basic functionality of a multiplexer and demultiplexer. Right. Multiplexer and demultiplexer. Now, let us understand about multiplexer. Later, we can see demultiplexer also clearly. So, what we discussed here, data available on multiple lines will be multiplexed onto single output line. But at given instant of time, only one input data will be selected on output line. Which input data is that? Decided by n select lines or control signals. N select lines or control signals. So if I say 2:1, example, if I say 2:1, how many select lines required? 2 power n, 2 power 1:1. So 2 power n inputs to 1 output. Here n equals to 1, one select line or control signal is sufficient. So the representation is like this. Here we have 0, 1, 2 input lines, and here we have a select line. 2 by 1 or 2:1. Your wish, what you are using. If I say here it is I0 and I1. Here we have output Y. Output Y. If you are observing S equal to 0, Y is getting I0. S equals to 1, Y is getting I1. Check it correctly. When S equal to 0, Y is getting I naught. When S equals to 1, Y is getting I1. Y is getting I1. So S equal to 0, I naught. S equals to 1, I1. So what is the functionality of this and what is that expression and how to implement? Let us see one by one. What is the expression for this? What is the output expression for this? What is the functionality when S equal to 0, Y equals to I naught, and S equals to 1, Y equals to I1 is a functionality. How many inputs are there on this? Three inputs, including control signal S. So yes, I1, I naught. There are three inputs, one output. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1. Then we need to write output depending on functionality. What is functionality? S equal to 0, I naught, S equals to 1, I1. When S equal to 0 in all these four, what should be the output? I naught. So whatever is there on I naught will be the output. Check it correctly. In these four combinations, S equal to 0, functionality is Y equals to I naught. So I naught 0, 1, 0, 1. I'm writing 0, 1, 0, 1. When S equals to 1, Y equals to I1. When S equals to 1, Y equals to I1 means here we have 0, 0, 1, 1. Let me write 0, 0, 1, 1. That is output depending on functionality. Then what should I do? Writing expression, right? So first let me give input combination numbers. Then I can write what is the output expression. So y is equals to sigma m of what is it? 1, 3, 6, 7. 1, 3, 6, 7. If I use a three variable k map to find minimal expression of y in terms of yes, I1, I naught. Yes, I1, I naught. 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. What is it here? 1, 3, 6, 7. Then if I group, this is one grouping, this is second grouping. Then what we are getting y? S equal to 0, S bar. Right, here we are getting I naught. Plus what we are getting here? Yes, I1. Check it correctly. So in this, I1 is changing, I naught is 1, S equal to S bar I naught. And here it is S equals to 1, not required, but simply I'm giving what we can do while proceeding to implement that. So finally, what is it here? S equal to 0, I naught, S equals to I1 with that functionality. If you are trying to implement output expression is S bar I naught plus S into I1. If I try to implement S bar I naught plus S into I1. The same we can implement using only NAND gates also. NAND gate, because AND OR can be replaced with the NAND, right? Yes. Here it is a I naught. And here again using NAND gate as inverter I1. This is another way of implementing 2:1 multiplexer. 2:1 multiplexer. Yes, 2:1 multiplexer. Moving next slide. If I say 4:1 mux or 4/1 mux, 4 inputs, 1 output. 4 inputs, 1 output. Bhavani, if you want to use I1 and I naught, it is redundant according to our earlier discussions. For prime implicants, we can group. I'm grouping directly for minimal, so you can do this. Yes, if you're grouping this, right, it is prime implicant, but it is not there in the minimal expression. Bhavani. And for yesterday's question, some of you are messaging. Yes, answer is homework question. What do you got answer? Please reply. Yes, yes. Correct. Yes. Right. Some people are mentioning 6 nanoseconds, which is wrong. Check it. Yes, most of you are correct. Yes. Yes, that's correct. So many of you are. What happened to truth table? Sai Kumar, is this wrong? Truth table? It is correct only. Proceed. Right. Okay. Okay. This is truth table. And after this 2:1, we have discussed. So answer is 10 nanoseconds. For yesterday's homework question, answer is 10 nanoseconds. Sai Kumar, twice or thrice I explained. Now again you are asking me, sir, were you out of the system? Yes. Yes, Triveni. So what is the functionality? Already I told you. Steps to design combinational circuit. So number of inputs, number of outputs, depending on functional, deciding outputs for each and every possible combination. Then finding minimal expression, drawing logic circuit. That's what we are doing. Right. So what is functionality? S equal to 0, y equals to I naught, S equals to 1, y equals to I1. Functionality is correct. From this representation, what we are understanding, S equal to 0, y equals to I naught, S equals to 1, y equals to I1. See, in this 4, S equals to 0. Then what is the output? I naught. That means whatever is there on I naught will be copied when S equals to 0. S equal to 0, y is I naught, functionality. So 0, 0, 1, 1, 0, 0, 1, 1. When S equal to 0. When S equals to 1, what is the output? I1. Whatever is there on I1 will be copied on Y. See, I1, 0, 0, 1, 1. In these, S equals to 1. When S equals to 1, Y equals to I1. What is I1? 0, 0, 1, 1. 0, 0, 1, 1. Right? Now, 4:1 mux. So 4:1 mux means 2 power 2:1 multiplexer. 2 power 2:1 multiplexer means we have 2 select lines and 4 input lines. Okay, okay, Saikma. Right. Okay. Now, 4:1 mux requires 4 input lines, 2 select lines, S1, S0, S1, S0. Now, what we can say here, inputs are I0, I1, I2, I3. When S1, S0 is 0, 0, I0 should be the output. When S1, S0 is 0, 1, I1 should be the output. When S1, S0 is 1, 0, I2 should be the output. When S1, S0 is 1, 1, I3 should be the output. Sometimes it may be given either 0, 0, 0, 1, 1, 0, 1, 1, or it may be given decimal equivalents of those also 0, 1, 2, 3. It may be given either vectors or decimal equivalents of vectors. When S1, S0 is 0, 0, Y is getting I0, 0, 1, I1, 1, 0, I2, 1, 1, I3, 1, 1, I3. So what we can write here, when 0, 0, I0 means, directly I am writing S1 bar, S0 bar, I naught. 0, 0, I naught. When S1, S0 is 0, 0, I naught should be the output. So 0, 0 means S1 bar, S0 bar, I naught plus 0, 1, I1. S1 bar, S0, I1 plus 1, 0, I2. S1, S0 bar, I2 plus 1, 1, I3 means S1, S0, I3. S1, S0, I3. Right? So if you want to implement, you can do that also. This is a 4:1 multiplexer. S1 bar, S0 bar, I0, S1 bar, S0, I1, S1, S0 bar, I2, S1, S0, I3. That is the output expression. Now, yes, we get same expressions. Now, if it is 8:1 mux or 8 by 1 mux, what is 8 to power 3? To power 3:1 multiplexer means how many select lines, sir? 3 select lines are 3 control signals. And here we have 8 input lines. Here S2, S1, S0, 3 select lines. We say I0, I1, I2, I3, I4, I5, I6, I7. And you can say here 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 8:1 mux. What is it here when S2, S1, S0 is 0, 0, 0, I0 should be the output, 0, 0, 1, I1, 0, 1, 0, I2, so and so, 1, 1, 1, I3. So I can use here either vectors or decimal equivalents of those vectors also. Then what is the output expression? When S2, S1, S0 is 0, 0, 0, I0 means S2 bar, S1 bar, S0 bar, I0 plus 0, 0, 1, I1 means S2 bar, S1 bar, S0, I1 plus S2 bar, S1, S0 bar, I2 plus S2 bar, S1, S0, I3 plus S2, S1 bar, S0 bar, I4 plus S2, S1 bar, S0, I5 plus S2, S1, S0 bar, I6 plus S2, S1, S0, I7. I7. So that is a output expression. You can implement, no need to implement every circuit. And I can say that 16:1 multiplexer means we have 4 select lines, S3, S2, S1, S0, for each and every combination, one of I0 to I15 will be the output. No need to write again 16:1 multiplexer, 32:1 multiplexer, 64:1 multiplexer, to power n:1 multiplexer. When we have n select lines or control signals, it can multiplex maximum to power n inputs. When we have n select lines or control signals, it can multiplex to power n input lines. Question is implement 4:1 mux using minimum number of 2:1 multiplexers. 2:1 multiplexers. So I need to implement 4:1 mux using 2:1 multiplexers. Then very simple, what we can say in the first stage, we need two number of 2:1 multiplexers, which are right, able to select four inputs, producing two outputs. Producing two outputs. Again, multiplexing these two using another 2:1 multiplexer. Another 2:1 multiplexer. Here it is 0, 1, 0, 1, 0, 1. Then if I say it is 2:1, 2:1, 2:1. Correct. Number of multiplexers required is 2 plus 1, it is 3. But what should be the select lines of each and every 2:1 multiplexer? To meet expected functionality S1, S0, Y, 0, 0, I0, 0, 1, I1, 1, 0, I2, 1, 1, I3. For this, what should be the select lines of each 2:1 multiplexer? That should be decided. First stage is always LSB select line. Remember this. Last stage is always MSB select line. First stage is always LSB select line. Last stage is MSB select line. Is this correct or not? Let us see. So when S naught is 0, check it correctly. When S naught is 0, what will be here? I naught, and here it will be I2. Right? When S1 is 0, Y is I naught. When S1 is 1, Y equals to I2. What is here? When S1 is 0, Y equals to I naught. When S1 equals to 1, Y equals to I2. Correct? When S1 is 0, Y equals to I naught. In this condition, when S1 equals to 1, Y equals to I2. That means when S1 is 0, S0 is 0, Y equals to I naught. Correct. When S1 is 1, S0 is 0. When S1 is 1, S0 is 0, it is I2. Yes, this is satisfied. Now, similarly, when S0 is equals to 1 in the first stage, here what we get I1, here what we get I3. Depending on S1, either I1 or I3 will be the output. So when S1 is 0, Y is getting I1. When S1 is 1, Y is getting I3. So when S1 is 0, Y is getting I1. When S1 is 1, Y is getting I3. Check it correctly. So when S1 is 0, I1. When S1 is 1, I3. So when S1, S0 is 0, 1, I1. Yes, correct. When S1, S0 is 1, 1, Y equals to I3. Yes, satisfied. It is satisfied. Right? These are 2:1 multiplexer which can be used to implement a 4:1 multiplexer. 4:1 multiplexer. Right? So first stage, two number of 2:1 multiplexer. Second stage, one 2:1 multiplexer. And what is select lines is first stage is LSB, last stage is MSB. First stage is LSB select lines, last stage is MSB select lines. MSB select lines. So this is a confirming expected functionality. Expected functionality. The minimum number of 2:1 multiplexers required is 2 plus 1 it is 3. 2 plus 1 it is 3. Moving to next slide. 8:1 mux using 2:1 muxes. Minimum number of 2:1 muxes. Then again say, what is it here? When we have 8 inputs, first stage, we need 4 number of 2:1 multiplexers. And here it is producing 4 outputs. To multiplex these 4 outputs, we need another 2 number of 2:1 multiplexers. Producing 2 outputs, again multiplexing these 2 using another 2:1 multiplexer. So 0, 1, 0, 1, 0, 1, 0, 1. Then what can be the select lines? Yes, not, yes, not, yes, not. Then S1, S1, and here it is S2. First stage is LSB, last stage is MSB. First stage is LSB, last stage is MSB. So if you are observing 4 plus 2 plus 1, it is 7 number of 2:1 multiplexer. To implement 4:1, 2 plus 1, it is 3. To implement 8:1, 4 plus 2 plus 1, it is 7. To implement 16:1 multiplexer, what is here? 8, 4, 2, 1, total 15. To implement a 16:1 multiplexer, it requires a 15 number of 2:1 multiplexer. To implement a 32:1 multiplexer, it requires a 31. To implement a 2 power n:1 multiplexer, it requires a 2 power n minus 1 number of 2:1 multiplexer. To implement 2 power n:1 multiplexer, the minimum number of 2:1 multiplexer required is 2 power n minus 1. The minimum number of 2:1 multiplexers required to implement 2 power n:1 multiplexer is 2 power n minus 1. 2 power n minus 1. 16:1 mux using 4:1 muxes. 16:1 multiplexer using 4:1 muxes. What do you mean by this, sir? We need to implement a 16:1 multiplexer using minimum number of 4:1 multiplexers. So here we need a 4 number of 4:1 multiplexers. Producing 4 outputs. To multiplex these, we need another 4:1 multiplexer. And what will be the select lines here? First stage LSB, 2 select lines, S1, S0, S1, S0, S1, S0, S1, S0, then S3, S2. S3, S2. If I say S3, S2, S1, S0 are select lines, so first stage is LSB, 2 select lines, S1, S0, last stage is MSB, S3, S2, S3, S2. That is a implementation of 16:1 multiplexer using minimum number of 4:1 multiplexer. Now, if you're understanding this, let us see how we can answer the questions which we can get in competitive exams. the minimum number of 4:1 multiplexers required to implement a 1024:1 multiplexer is dash. Don't try to implement just say the number. Okay. Okay. Some people are lagging here. 4 inputs are there. To multiplex 4, we need to use the 2 number of 2:1 multiplexer, producing 2 outputs. Finally, we need 1 output. By multiplexing these 2, we are getting 1 output. And if it is 8:1 multiplexer, 8 inputs. In the first stage, we need 4 number of 2:1 multiplexers, producing 4 outputs. To multiply these 4 outputs, we use 2 number of 2:1 multiplexers, producing 2 outputs. We are using another 2:1 multiplexer to produce only 1 output. And it is a 16:1 multiplexer using 4 number of 4:1 multiplexer in first stage. We can accept a 16 out, 16 inputs, producing 4 outputs. To multiplex these, we are using another 4:1 multiplexer. Yes. Okay. Many of you are answering correctly. Some of you are doing a mistake. I can see what you are doing. Very good. Yes. Excellent. Most of you are answering correctly. Let us. How many input lines are there? 1024. Am I right? Is equals to 2 power 10. 2 power 10. The number of select lines will be 10. 2 power 10 is to 1 multiplexer means we have 10 select lines. Let us see how it can be implemented. So 1024 input lines are there. Using 4:1 multiplexers means in the first stage we need 256 number of 4:1 multiplexers, because each 4:1 multiplexer can accept only 4 inputs. So total 1024 input lines are there. So to accept 1024 input lines, we need 256 number of 4:1 multiplexers in first stage, right? After first stage, how many output lines are there? Yes, obviously 256 output lines are there. Check it correctly. When I am using 256 number of 4:1 multiplexers to accept 1024 input lines, so it is producing 256 output lines in the first stage. These 256 output lines again I need to multiplex using 4:1 multiplexers. In the second stage, it requires 64 number of 4:1 multiplexers. In the second stage, it needs 64 number of 4:1 multiplexers. Right? After second stage, we have now 64 output lines. 64 output lines. To multiplex these 64 output lines, we need 16 number of 4:1 multiplexers in third stage. After third stage, now we have how many output lines? 16 lines are there, because 16 number of 4:1 multiplexers are there, and then 16 output lines are there. To multiplex these 16, we need a 4 number of 4:1 multiplexers. To multiplex these 4, we need 1 number of 4:1 multiplexers. Finally, 256 in first stage, 64 in second stage, 16 in third stage, 4 and 1 is a 341. 340. Be clear about the concept. Don't go with your assumptions like first stage 256 plus 1. That is general assumption. No. So there we have seen that one or two stages only, but here we have a multi-stages. It is 5 stages we have. Why you are confirming 5 stages, sir? As I am using 4:1 multiplexer, sir. As I am using 4:1 multiplexer. So it can accept only 2 select lines, sir. What is it here? Implementation using 4:1 multiplexers. Implementation using 4:1 multiplexer. 4:1 multiplexer is having accepting 2 select lines. The total number of select lines is 10. Total number of select lines is 10. In each stage, it can accept only 2 select lines. Then total number of stages must be 5. 1, 2, 3, 4, 5. Verify whether we have done correctly or not. Yes, it is a 341 4:1 multiplexers required to implement a 2 power 10:1 multiplexer. 2 power 10:1 multiplexer. So most of you have answered correctly. Some of you are doing a mistake. Just check it where you have done a mistake. Yes. Yes, Arun Revant. Yes. Very good. Yes. Yes. Everyone is doing correctly now after understanding the logic. No one is answering wrongly. Deepa, please check. You are forgetting the last one. One is less in your answer. Last one. Last one you are neglecting. Once you are getting 8, again we need to have one more to multiplex this 8. Deepa. You guys see, check your answer. Excellent. Everyone. Sunitha, check it up. Pranita, check it up. Yes. Okay. Okay. I'll do that. Yes. 2 power 12, 4096 divided by 8. It requires 512 number of 8:1 multiplexers in the first stage. 4096 inputs can be multiplexed using 512 8:1 multiplexers in first stage. After first stage, we have 512 output lines. To multiplex these 512 output lines, we need how many? 64 number of, right? 64 number of 8:1 multiplexers. So after second stage, we have 64 output lines. To multiplex these, we need 8 number of 8:1 multiplexer. So after this, we have 8 output lines. To multiplex these, we need one more. So finally, what is it here? 512 plus 64 plus 8 plus 1, it is 585. There is a possibility for forgetting last one. Every batch have been mentioning this. So you may reach that 8, there you may be stopping. No, no. 8 also must be multiplexed to get one output. That is 8 is to 1 multiplexer. One more is required. That is 585. Yes. Yes. Most of you or all of you have answered correctly, except a few, one or two. Yes. Hold on, Sajjan Singh. Hold on. Now, implement 9:1 mux using minimum number of 2:1 muxes. Or what is the minimum number of 2:1 multiplexers required to implement 9:1 mux? Bhaskar, that is correct. Just use the formula, you can get it. If it is for 2:1 multiplexer. Yeah, Anand. Yes, if required, what do you do? So, do you think that always it must be 2 power n:1 multiplexer only? No. If it is a 9:1 multiplexer, how optimal you can implement using 2:1 multiplexers? Using 2:1 multiplexers. Okay, let me check how it can be implemented. When we are saying that, 9:1 multiplexer, how many select lines required? When it is 9:1 multiplexer, when it is a 9:1 multiplexer, yes. So to implement 9:1 multiplexer, the number of select lines required, yes, number of select lines required is 4. Number of select lines required is 4 because with 3 select lines, maximum we can differentiate 8 inputs. To differentiate 9 inputs, the minimum number of select lines required is 4. Once again, the minimum number of select lines required is 4 because with the 3 maximum we can differentiate 8 inputs. So to multiplex 9 inputs, we need 4 select lines. If I say S3, S2, S1, S0 and Y, what can be the function? Let us see. 0, 0, 0, 0. It is a I0. 0001, it is a I1. 0010, it is a I2. 0011, it is a I3. 0100, it is a I4. 0101, it is a I5. 0110, it is a I6. 0111, it is a I7. 1000, it is I8. I8. That's it. If you are understanding this, nothing is there in this. If you are observing, when S3 is 0, when S3 is 0, for all this, S3 is 0, depending on S2, S1, S0, one of I0 to I7 is output. When S3 is 1, no alternative, only I8. When S3 is 0, depending on S2, S1, S0, one of I0 to I7 is output. When S3 is 1, only I8. Only I8. Let us see how it can be. Now, here if I say I0, I1, I2, I3, I4, I5, I6, I7. Here it is Y. What we get here, depending on, if I use select lines, yes not, yes not, yes not, yes not, here S1, S1, here it is S2. Depending on S2, S1, S0, one of I0 to I7 is output here. That must be final output when S3 is 0. If I say it is S3, when S3 is 0, that is output. When S3 is 1, only I8. When S3 is 1, only I8. Directly we are connecting. That is a final output. Why? Yes. What is happening here? Observe truth table correctly. Or observe this table. When S3 is 0, there is a possibility for I0 to I7 depending on S2, S1, S0. Depending on S2, S1, S0, one of I0 to I7 is here. Right? That is final output when S3 is 0. Yes, when S3 is 0, there is I0 to I7 depending on S2, S1, S0. When S3 is 1, only I8. When S3 is 1, only I8. So minimum number of 2:1 multiplexers required to implement this is 8. Don't think that is it required, is it possible, right? All these questions, please throw all those questions out, then think right correctly. Okay, okay, okay. Logically proceed, you will get correct answers. If I say 10:1, for example, 10:1 multiplexer, if it is a 10:1 multiplexer, then what we can write? 1001, it is a I9. Right? Then what is it here? When S3 is 1, there is a possibility for I8 and I9. When S3 is 1, there is a possibility for I8 and I9. Those are depending on S0. S0 is differentiating I8 and I9. Then what we can have here? right? When S3 is 1, there is a possibility for I8 and I9. Those two are differentiated with the S0. Correct? You can extend. If you find any difficult, let me know. Try 11:1 multiplexer. Let me know if you find difficulty. 11:1 multiplexer. So up to 10:1 multiplexer we have implemented. If you try 11:1 multiplexer, let me know if you find any difficulty. Right. Implement 2:1 mux using 4:1 mux. Yes, Pratyush. Yes, you are right. Yes, Shanmugh, you are right. Implement 2:1 mux using 4:1 mux. Using 4:1 mux. What is required? 2:1 multiplexer. What is available? 4:1 mux. Available is 4:1. Required is 2:1. How it can be implemented? First, let me write a functionality. Yes, y 0 I0 1 I1. This is a expected functionality. What is available? 4:1 multiplexer. Yes, 0 1 2 3 4:1 mux. And here we have S1 S0 select range. Now, when S1 S0 select lines are there, but functionalities of only one select line. I can do by shorting these two, connecting to S. S equal to 0. S1 S0 is 0 0. 0th. There it must be I0. When S equals to 1, S1 S0 is 1 1. That means here it must be I1. What about remaining? You can connect 0, you can connect to 1, you can connect like this, I not only or I1 only, not a problem. This is why. Or you can connect 0 also, you can connect 1 also, not a problem. Because those are not getting selected at all. When S equal to 0, 0, 0 possible. That means this line is possible. When S equals to 1, 1, 1, this is possible. This is possible. So for 0, 1 and 1, 0 on select lines, it is not possible. For 0, 1 and 1, 0, it is not possible. So this is one way we can implement that. Other possibilities also, let us try. Let us see other possibilities also. What is the other possibilities is, for example, I can connect here 0 and S. Then what we get here, when S equal to 0, 0, 0, that means it is I0. When S equals to 1, 0, 1, here I1. What about remaining? Maybe connecting 0, maybe connecting 1, maybe connecting any logic, not a problem. Because the functionality it is not getting selected. Another possibility, why should I use 0 here? I can use 1 also. When S equal to 0, what we are getting? 1, 0. When S equals to 1, 1, 1. For S equal to 0, I0. For S equals to 1, I1. Because 1, yes. So now I'm connecting here zeros, not a problem. So I can swap here. S can be connected here. S not can be 0 or 1. Or you can use S and S bar or S bar and S. Your wish. There are n number of ways to implement using 4:1 multiplexer. While implementing lower order from higher order, we are observing multiple ways. And some of you may be doubting, why do we need this? Whenever it is required higher order, we can implement. Whenever it is required lower order, how or why is it required? You may be getting a doubt. Let me ask you a question. Then you may understand the importance of this. I hope you are understanding. Any questions here? You can type in the chat box. Chakrabarti, I did not ask a number because it can be only one and required many. Now, question is, implement 8:1 mux using minimum number of. What it means, Manikanta? What it means? I didn't understand what you're expecting. Yes. Now, not number, the implementation is also important. The logic is also important. Let us see how it is. So, first we use two number of 4:1 multiplexers. Here it is accepting 4 plus 4, 8 inputs. Let me say internally we have x1, x0. Internally we have x1, x0. Then what should I do? I use S1, S0 as a select lines. Producing two outputs. These two can be multiplexed using again 4:1 multiplexer. But required is what? 2:1 multiplexer. Available is 4:1 multiplexers only. But I need a 2:1 multiplexer functionality. Now you may understand what is happening here. Right? This question already given in ESC objective. Minimum number of 4:1 multiplexers required to implement a 8:1 multiplexer. I think someone was asking this type of question only in chat box, sir. Yes. Yes. Again, many ways here. Implementing 2:1, using 4:1, many ways. Yes. Yes, Pratyush. I'm using one in that. In this circuit, I cannot show you that many. right? I'm showing you only one. Moving to next slide. Yes. Now, from day one, we have been saying about multiplexer. Multiplexer is universal, right? Using only muxes. Annapurni, using only muxes. Muxes only. Read the question. Annapurni, right? Even though you are using logic gates, again you are going to implement the same, right? Yeah, wait for doubt session or question hour, right? If you have missed any of the discussions, please wait for doubt session or question hour. So from day one, Purna Chandra, wait, we'll discuss. So from day one, we have been saying that multiplexer is also universal. Saying about a multiplexer, multiplexer is universal. Let us prove universalness of multiplexer. Universalness of multiplexer. So when can we say multiplexer is universal? If it is possible to implement three basic functions using only multiplexers, then we can say it is universal. Then we can say it is universal. Let us see what is that here. So first, let me implement NOT gate functionality using multiplexer. Using multiplexer. So NOT gate functionality A Y is equals to A bar 0 1 1 0. Any questions? A is 0, Y is 1. When A is 1, Y is 0. Let us implement this using 2:1 multiplexer. This is available. We would like to implement this one. Let us see how it is. So when S equal to 0, Y equals to I naught. When S equals to 1, Y equals to I1 is functionality. Now, how many variable function is that? Only one variable. How many select lines we have here? Only one. I can connect this one variable as a select line. I can connect this one variable as select line, right? When S equal to 0, I naught, when S equals to I1 means when A equal to 0, S equal to 0, Y equals to I naught. When A equals to 1, S equals to 1, Y equals to I1. When A equal to 0, what we are expecting output? 1. When A equals to 1, what we are expecting output? 0. When A equal to 0, S equal to 0, Y equals to I naught. When A equals to 1, S equals to 1, Y equals to I1. Right? So when A equal to 0, output should be 1. When A equals to 1, output should be 0. Then if I write output expression S bar I naught plus S into I1. S bar, in place of S, what we have? A. A bar, I naught is what? 1 plus A, I1 is what? 0. Then A bar plus 0, which is A bar. That's what we are expecting, A bar. Simple thing is A equal to 0, I naught is output. When A equal to 0, output should be 1. So I naught is 1. When A equals to 1, I1 is output. When A equals to 1, output should be 0. So I1 is 0. That's it. Not gate is possible. Similarly, let us implement a OR gate. A, B, Y is equals to A plus B. 0, 0, 0, 1, 1, 0, 1, 1. 0, 0, 0, 1, 1, 0, 1, 1. Then what is the output here? 0, 1, 1, 1. Now, multiplexer, 2:1 multiplexer I am using. Right. So, multiplexer is having how many select lines? Only one select line. Function is of how many variables? Two variables. Function is of how many variables? Two variables. Multiplexer is having only one select line. In these two variables, I can use only one variable as select lines. In these two variables, I can use only one variable as select lines. Either A or B, your wish. I'm using A here. If A equal to 0, what is the output? B is 0, output 0, B is 1, output is 1. Means output is B. When A equal to 0, output is B. Check it correctly. When A equal to 0, S equal to 0, Y equals to I naught. But when A equal to 0, what should be the output? B is 0, output 0, B is 1, output is 1. What is it here? It is a B. When A equals to 1, when A equals to 1, what we are getting here? B is 0, output is 1. B is 1, output is 1. Irrespective of B, output is 1 or A itself. Check it correctly. When A equals to 1, irrespective of B, output is 1 or A itself. What we can write here? 1 or A. 1 or A. When A equals to 1, S equals to 1, Y equals to I1. When A equals to 1, when A equals to 1, irrespective of B, output is 1 or A itself. You can use 1 or A, not a problem. Functionality will be same. Let us verify. S bar I naught plus S into I1. That means A bar, what is the I naught? B plus S means A. I1 is what? 1 or A. I1 is 1 or A and 1. A or A and A also, A itself. So, what is the resultant here? A bar plus A and with B plus A. A bar plus A is 1. Resultant is A plus B. Next, AND gate. Let us implement AND gate. A, B, Y is equals to A and B. 0, 0, 0, 1, 1, 0, 1, 1. What is the output? 0, 0, 0, 1. Let us implement this using 2:1 multiplexer. 0, 1, 2:1 multiplexer. So now I can use one variable as select line. Function is of two variables, but multiplexer is having only one select line. I can use either A or B as select line. Let me use A as select line. When A equal to 0, irrespective of B, output is 0. When A equal to 0, irrespective of B, output is 0 or A itself. When A equals to 1, when A equals to 1, what is the output? B. B is 0, output 0, B is 1, output 0. Output is B. When A equal to 0, output is 0 or A itself. When A equals to 1, output is B. So here we can write 0 or A. And here it is B. Now if I write output expression, S bar I naught plus S into I1. S into I1. S bar means A bar. What is the I naught? You can use 0, you can use A. A bar and 0. 0. A bar and A also 0. Plus A, what is the I1? B. Resultant is what? A. Yes. As it is possible to implement NOT gate, OR gate, AND gate, then it is possible to implement any logic function in universe. So using only multiplexers, we can implement any logic function. Using only multiplexers, we can implement any logic function. So multiplexer is universal. Multiplexer is universal. Multiplexer is universal. Similarly, complete that implementation of two input NOR, NAND, XOR, XNOR. Please try everyone on your own. Two input NOR, NAND, XOR, XNOR using only 2:1 multiplexers. Complete implementation of two input NOR, NAND, XOR, XNOR using only 2:1 multiplexers. Let us see two input NOR, NAND, XOR, XNOR implementation using 2:1 multiplexers. Using 2:1 multiplexers. NOR. If I say two input NOR, A, B, Y is equals to A plus B whole bar, which is A bar dot B bar. 0, 0, 0, 1, 1, 0, 1, 1. Then here we have 1, 0, 0. Let us implement this using 2:1 multiplexers only. Zero, 1, 2:1 select line. I can use one variable as select line. Any one of these as select line, either A or B. Let me use A as select line. When A equal to 0, then B is 0, output is 1, B is 1, output is 0. That means it is a B bar. It is a B bar. To get B bar, again we are using 2:1 multiplexer. It is connected to B. And here it is 1, 0. Here we are getting B bar. Check it correctly. When A equal to 0, we are getting B bar. Yes, when A equal to 0, it is B bar. To get B bar, another 2:1 multiplexer. When A equals to 1, what is the output? 0. Don't say A bar unnecessarily. Irrespective of B, output is 0. If I say A bar, I need to use another 2:1 multiplexer. Not required. When A equals to 1, irrespective of B, output is 0. Verify that output expression. So S bar I naught plus S into I1. So A bar I naught is what? B bar plus A I1 is 0. A bar B bar, which is A plus B whole bar. So NOR gate implementation using 2:1 multiplexer. Then NAND gate. A, B, Y is equals to What is it here? AB whole bar. A bar plus B bar. 0, 0, 0, 1, 1, 0, 1, 1. Then what is it output? This is the output. Select. I can use one variable as select line, either A or B, not a problem. I use A as select line. When A equal to 0, output is what? 1. When A equals to 1, output is B bar. Here it is 1, 0. Here it is B. Here it is B bar. Then S bar I naught plus S into I1. A bar I naught is 1. A I1 is B bar. Then A bar plus A and with A bar plus B bar. A bar plus A is 1. Resultant is A bar plus B bar, which is AB whole bar. Which is AB whole bar. Not NAND. It is not NAND. Next. Exclusive OR, XOR. A, B, Y is equals to A XOR B. 0, 0, 0, 1, 1, 0, 1, 1. Let me complete quickly. Some of you or most of you might have done already. Let me complete implementation using 2:1 multiplexers. 0, 1, 2:1 select line. If I use A as select line, A equal to 0, output is B. A equals to 1, output is B bar. Then what we get here, Y? S bar I naught plus S into I1. S bar means A bar. I naught is B. S means A. I1 is B bar. What is this? A XOR B. Similarly, exclusive NOR. A, B, Y, A XOR B. 0, 0, 0, 1, 1, 0, 1, 1. 1, 0, 0, 1. Let us implement using 2:1 multiplexers. Let me use one variable as select line. Yes, connected to A. If A equal to 0, here we get a B bar. If A equals to 1, here we are getting B. So S bar I naught plus S into I1. A bar I naught is what? B bar. Plus A I1 is what? B. So it is A XOR B. A XOR B. A XOR. Now, for example, if I would like to implement OR function using 4:1 multiplexer. OR function using 4:1 multiplexer. Check it correctly. If I would like to implement 2-input OR gate functionality using 4:1 mux. Here we have two select lines. What is the function we are implementing? 0, 0, 0, 1, 1, 0, 1, 1. Output is 0, 1, 1, 1. I would like to implement a 2-input OR gate functionality using 2-input OR gate functionality using. Okay. Okay. Am I speed? Am I speed? Am I running with high speed? Okay. Okay. I'll come. Okay. I'll slow down. I'll slow down. Okay. Okay. 5G. Sahil. Okay. You can inform me in such cases. Unknowingly, I may be, because these are simple topics. With respect to multiplexer, yeah. What is it? SHSG? High speed jet? Surya Teja? What is it? SHSG? Okay. Oh, why do we need say sorry? Okay. Okay. If I'm speeder, I'll slow down because I'm expecting these are very simple. You might be knowing already. Oh, hypersonic missile. Okay. Okay. You would have informed me, not a problem. Because as it is not a physical class or offline class, the two, if I don't get any messages also, it will be like direct to memory access, right? It will be direct to memory access, DMA. It is transferring data to this output device directly from memory in without interference of processing. From memory, it is transferring. Right? It happens, sir. Okay. Okay. If you are interrupting, okay. Okay, then I'll slow down. Okay. Any doubt? Which one you want me to explain in the previous? I will explain. Whichever you want, please let me know. I'll help you. So far we have done. Yeah, even I'm expecting. Ankur Kashyap, even I'm expecting. Okay, XOR and XOR. Okay. I'll explain XOR and XOR. Anything else? Okay. People are asking for XOR and XOR. Okay. Anything else? Anything else you want me to explain? Manisha, S0 and S1 will be B and A. Okay. So this one you are explaining. Okay. I'll come to that once again. Some of your friends have been requesting for XOR and XNOR. Let me go with this. Exclusive OR and exclusive NOR. See, I am using 2:1 multiplexer. For select line, I can use only one variable, either A or B. I am using A here. When A equal to 0, functionality if you are observing, when A equal to 0, just write this. When A equal to 0, what is it here? B. When A equals to 1, what is it here? B bar. When A equal to 0, it is B. When A equals to 1, it is B bar. That's what I am writing. When A equal to 0, I naught, it is B. When A equals to 1, I1, it is B bar. To get B bar, again, I am using 2:1 multiplexer. XOR. Coming to XNOR. What is it here? I can use one variable as select line. In that A equal to 0, what is that output we are expecting? B bar. When A equals to 1, output is again B. Output is again B. When A equal to 0, it is B bar. To get B bar, I am using 2:1 multiplexer. When A equals to 1, what we are expecting? B. B is correct. That's it. Still any more doubts? Still any more doubts? Yes. Yes, Pratyush, but let me do. My best. NAND gate. 0, what we are getting? 1. 1, what we are getting? B bar. A is 0, 1, A is 1, B bar. See, when A equal to 0, irrespective of B, output is 1. When A equals to 1, what is that? B is 0, output is 1, B is 1, output is 1, it is B bar. So A equal to 0, it is 1, A equals to 1, it is B bar. Shubham. Any more doubts? Okay. Yeah, Sai Kumar, I'm going to that only. Please wait. I think you are playing a joke. Haven't discussed the 4:1 implementation. Please wait. Let me come to that. I'm going to that only. Okay. So I want to implement two input OR gate functionality using 4:1 multiplexer. Then what can I do? I can go with the select lines, two variables. AB connected to the select lines. Then what we get here? When AB 0, 0, I not. But when AB 0, 0, what is the output? 0. Directly we are connecting outputs expected. When number of input variables is equals number of select lines, implementation becomes easy. AB 0, 0, output 0, 0 connected. AB 0, 1, output is 1. Here it is 1. When AB 1, 0, it is 1. When AB 1, 1, it is 1. Simple. Now instead of writing truth table directly, we can complete. Let me implement AND gate also. AND gate using 4:1 mux. S1, S0. 0, 1, 2, 3. So if I use AB as select lines, AB 0, 0, output is 0. AB 0, 1, output is 0. AB 1, 0, output is 0. AB 1, 1, output is 1. AND function. AND function. AND function, right? Simple. Because AB, Y, if I write 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. For AB 1, 1 only, output is 1, remaining 0. These are A and B. If it is XOR, if it is two input XOR using 4:1 multiplexer. If I want to get A XOR B, AB can be connected to select lines. What is the input, sir? 0, 1, 1, 0. If it is XNOR, if I use AB, here it is A XOR B, and to get A XNOR B, what should be the inputs? 1, 0, 0, 1. I know the tables, sir. Directly I'm writing. What should be the inputs to get A XNOR B? Nagalingeshwarao, there is homework for you. Right. Not a big question. Please try. For 7:1, it requires 3. For 9:1, it requires 4. Chakravarti. Now, if you are understanding these two, let me do some more concepts with respect to this. What will be the output? Please respond in chat box. What will be the final output? What will be the final output? This is a circuit. What is that output expression? What is the output expression? Yes. Yes. Right. Correct. It is A XOR B XOR C. It is A XOR B XOR C. You might have understood A XOR B, again XORing with C is A XOR B XOR C. Now, please respond for this question also. What is the F? Yes. Sai Kumar, please check it. Very good. Most of you have observed correct. It is A XOR B XOR C. No, it is A XOR B XORing with C. Here it is A XOR B. Then again XORing with C is equals to A XOR B XOR C. It is not A XOR B XOR C. I'm checking how much you are following my class. Nagalingeshwara, what is that one? Where do you get one? Is A XOR B XOR C. The property I have discussed. From that only I have framed this question. Right? Any doubts? So in these previous discussions, what we observed, when number of input variables is equals to number of select lines, directly connecting that variables as select lines, min terms are connected to 1, max terms are connected to 0. Min terms are connected to 1, max terms are connected to 0. Maunika, what happened? Wait for question hour. Any doubts? You can type in the chat box. So from this, what we have understood is when number of input variables is equals to number of select lines, when number of input variables is equals to number of select lines, it is easy by connecting variables as select lines. Min terms are connected to 1, max terms are connected to 0. Max terms are connected to 0. Right? And with this, once again, we are revising the property we have discussed. A XNOR B, XNORing with C is not equals to A XNOR B XNOR C. The property, once again, I'm reminding. So, Manikanta, are you there? Okay. Let us see questions which we have been getting in objective exams as well as conventional also. We have been getting questions based on this. Let us see what can be that. Question is 1, 2, 6, 7 using 8:1 mux, 4:1 mux and logic gates. Very simple. First part is what? 8:1 multiplexer. Eight is to 1 mux. S2, S1, S0. 0, 1, 2, 3, 4, 5, 6, 7. S2, S1, S0 connected to A, B, C directly. And here 0 is max term, 1 is min term, 2 is min term, right? 3, 4, 5 are max term, 6 and 7 are min terms. That is f of a comma b comma c. F of a comma b comma c. The same if I ask you to implement like this, or partial implementation is given, then what do you do? S2, S1, S0. If I give a partial implementation like this, then what I ask, what is the inputs I0, I1, I2, I3, so on, so I7 in order? 4, 5, 6, 7, 8:1 mux. Here it is used like this. Then what is it here? F of a comma b comma c. F of a comma b comma c. Then what will be the inputs? Then what will be the inputs? Whatever the function it is specified is sigma m of 1, 2, 6, 7 with order ABC, A bar, B bar, C plus A bar, B, C bar plus, you cannot write here, just let me go to next slide. What is given? F of A comma B comma C is equals to sigma m of 1, 2, 6, 7. Then what we can write? A bar B bar C plus A bar B C bar plus A B C bar plus A B C. If same S2, S1 is not connected to A B C, then would have been same. But order of the variables is changed. Now what should I write? C B bar A bar plus C bar B A bar plus C bar B A plus C B A. Now, with respect to new variables order, 1, 0, 0, 0, 1, 0, 0, 1, 1, 1, 1, 1. Then what is it here? Sigma m of, what is this? 4, 2, 3, 7. So, 2, 3, 4, 7. 2, 3, 4, 7. The function with respect to new variables order, just numbers are changing. Functionality is not changing because A bar B bar C is equals to C B bar A bar. A bar B C bar equals C bar B A bar. And all these are same. Functionality is not changing, but representation is changing. Variables order is changing. Min-term numbers are changing with respect to new variables order. I clearly mentioned in Boolean algebra itself. While defining combination numbers, which variables order you are using is also important. So with respect to new variables order, the minterms are 2, 3, 4, 7, 2, 3, 4, 7. So let me say that 2, 3, 4, 7 are minterms. 2, 3, 4, 7 are minterms. Remaining are max terms. Remaining are max terms. That's it. It may be given any order. You must be in a position to specify what is the inputs, because partial implementations are specified. They are asking what is the inputs I0 to I7 in order. I0 to I7 in order, they are asking you to write In the options they are giving, we have to choose, or if it is conventional, they may be asking you to implement also. So I would like to ask one more thing here. Take a photo or snapshot if you are doing that. Otherwise, I'm going to modify here. Instead of CBA, if it is now BCA, BCA. Then what will be the inputs? BCA. The same we can rewrite it as a BCA. Then what we can write? B bar C A bar plus B C bar A bar plus B C bar A plus B C A. Right? 0 1 0 1 0 0 1 0 1 1 1 1 is equal to sigma m of what is it here? 2 4 5 7 2 4 5 7 2 4 5 7 2 4 5 7 are min terms. 2 4 5 7 are min terms. Remaining are max terms. It may be given any order. You must be in a position to answer correctly. So don't think that it will be ABC only. ABC can be corrected directly. You can use 1 2 6 7 are min terms, remaining are max terms. That is easy. So they want to twist you. If they want to twist you, they may be changing variables order. This is what I've been saying. With respect to variables order specified, you need to give input combination numbers. With respect to variables order specified, you need to give input combination numbers. That's what we are doing in this. Check it. So, second part of the question. F of A comma B comma C equals to sigma m of 1 2 6 7. 1 2 6 7 is to be implemented using 4:1 multiplexer if required additional logic gates. If required additional logic gates. 4:1 mux. In this, it may be given partial implementation. It may be given partial implementation. That means it may be given AB as select lines. It may be given BA as select lines. It may be given BC as select lines. It may be given CB as select lines. It may be given any of the two, any of the order. Irrespective of that, you must be in a position to specify what is I0, I1, I2, I3. If I use AB as select line, simple order, then what should be the inputs? To complete implementation of this F of A comma B comma C, what should I do? Let me use that S1 S0 if S1 S0 0 0 0 1 1 0 1 1. So for S1 S0 0 0 I0 0 1 I1 1 0 I2 1 1 I3. But S1 is not connected to AB. AB, all possibilities complete. 0 0 0 1 1 0 1 1. Now C can be 0, C can be 1. Let me use that C bar and C. Here also you can use A bar, B bar, A bar, B, A, B bar, A, B. Your convenience. I am using 0 0 0 1 1 0 1 1. Here you can use A bar, B bar, A bar, B, A, B bar, A, B also. Not a problem. With respect to this order itself, let me write input combination numbers. Which order is that? ABC. ABC 0 0 0 0. ABC 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. What we have done, writing input combination numbers with ABC order. With ABC order, whichever the min terms are there, let us round up those. 1, 2, 6, 7. Simple way, writing input combination numbers, whichever the variables order we have used to write input combination number, with respect to same order, which are the minterms? 1, 2, 6, 7. So round up those minterms. And after that, going through each and every column. What is here? I0 is rounded off C. I1, C bar is rounded off. I2, nothing is rounded off, 0. I3, both are rounded up. That means C bar plus C, it is 1. C bar plus C, it is 1. Check it correctly. In this I0 column C, I1 column C bar, I2 column, nothing is rounded up, means 0. I3 column, both C bar and C rounded up, means C bar plus C, 1. So now completing implementation, what is it here? Here it is C, next C bar, next 0, next 1. Instead of this, if it is given like this, partial implementation is given, which is S1, S0 connected to, if you are observing I'm speeder, please give me an indication. Give me a flag. I will slow down. If I connect to BC as select line, what should be the inputs? To implement f of a comma b comma c, if I use BC as select line, what will be the inputs? Chakrabarti, here in this I3 column, if you are observing, both are rounded off. Which one is that? C bar, C. C bar plus C. It is a 1. That's what I'm writing. Only C bar, nothing 0. Both C bar plus C, it is 1. Now here, BC if I am using as select line, sir. Let us see how it can be implemented. S1, S0, 0, 0, 0, 1, 1, 0, 1, 1. Then S1, S0 connected to BC means what can be here? A bar, 0, A, 1. These are I0, I1, I2, I3. Right? ABC, what we have here? 0, 0, 0, 0, 0, 0, 1, 1. ABC, I am using order. 0, 1, 0, it is 2. 0, 1, 1, 3. 1, 0, 0, 4. 1, 0, 1, 5. 1, 1, 0, 6. 1, 1, 1, it is 7. What is the function? F of A comma B comma C equals to sigma M of 1, 2, 6, 7. Then round of given minterm numbers. 1, 2, 6, 7. I0, nothing is round of 0. I1, A bar is round of. I2, both are round of. A bar plus A, 1. And in I3, only A. So implementation 0. Next, A bar. Next, 1. Next, A. Right? You can try other variables order also. I can use that AC or CA. Try all those. Now, moving to next slide. For 8:1, I'm giving variables also for select lines. Instead of going with simple order and multiple times, instead of doing that, I am giving you what should be used. If I use A, D, B, then what should be the implementation? A, D, B. Then f of A comma B comma C comma D. F of A comma B comma C comma D. Specify what should be the inputs, I0, I1, I2, so and so, I7. Right. What can we do? Same procedure. S2, S1, S0. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Here it is I0, I1, I2, I3, I4, I5, I6, I7. Then S2, S1 are connected to ADB. And here it is C equal to 0, C equals to 1. Writing combination numbers. If you are observing all are zeros, no doubt it is 0. And here, these three and this one, if you are observing, only B is 1, remaining are zeros. That means A, B, C, D, 0, 1, 0, 0, it is 4. It is 4. But here A is 0, B is 1, C, D are 0, 0, it is 4. And here it is D is 1, it is a 1. And BD are 1 means 0, 1, 0, 1, it is a 5. Check it correctly. And here A is 1, 8. Here A and B are 1, 1, 1, 0, 0, it is 12. And A and D are 1, it is 9. A, B, D are 1 means 1, 1, 0, 1, it is 30. If anyone has any doubt how am I writing numbers, please let me know. Yes, Pavani, let me complete. Second column is nothing but plus 2. Because C equal to 0, A, B, C, D positions if you are observing 2 power 0, 2 power 1, 2 power 2, 2 power 3. This was 0, 2 was not added. When it is 1, 2 will be getting added. First row and second row difference is C equal to 0, C equals to 1 only. Here it is 2, 6, 3, 7, 10, 14, 11, 15. Check it. Even though you are using variables order and substituting, you will be getting same. Did I do any mistake? Check it. I've done correctly. Bhaskar, check it. I did correctly. I hope. Confident. At I1, no. With A, B, C, D order, I'm writing numbers. See, in this position, what we have here, B only 1, AD are 0, 0, C is 0. In this position, if you are observing, B is 1, ADB. Here, B is 1. So, A is 0, B is 1, C is 0, D is 0. That means A, B, C, D is 0, 1, 0, 0. 0, 1. Order is A, B, C, D, but here it is used ADB. Complex order, you need to accept. Not only simple orders, simple questions. Saujanya. Now round off given minterm numbers 1, 2, 3, 4, 7, 8, 9, 10, 12, 13, 15. Correct. What we get here? C. What we get here? C bar. Here it is 1. Here it is C. Here it is 1. Here it is C bar. C bar 1. I hope you can write it. So let me take it as C. Then it is C bar. Next is 1. Next is C. Next is 1. Next is C bar. C bar. Next is 1. If ADBC expression or function itself is given, then we can go with 0, 1, 2, 3, 4, 5, so and so. 0, 1, 2, 3, 4, 5. Because you are saying that A, D, B and C. So then it becomes 0, 1, 2, 3, 4, 5, 6, 7, 18, so and so, 14, 15. Then with respect to the ADBC order, the numbers which are given min-term should be used. Chakravarti. Yeah, Param. It may be given any order. Partial implementation will be given. Partial implementation will be given means in this S2, S1, S0 may be connected any of the variables, any of the order. Then they are asking options, objective questions. In that they are asking what is I0, I1, I2, I3, so and so, I7 in order. For that they may be using any order. That is the reason I have taken directly complex instead of using ABC. You may be comfortable with ABC, right? But in the exam, they may be giving ABC, they may not be giving ABC. To get practice with the complex order, I have taken this one. Param, right? So accept it. Yes. Let us go to second part of the question. F of A comma B comma C comma D equals to sigma M of 1, 2, 3, next 4, 7, 8, 9, 10, 12, 13, 15. What is required here? Second part of the question, using 4:1 multiplexer and required logic gates. Here, if input variables to the select line specified, we go with that. Otherwise, we can go with our own order. If it is conventional, if it is specified order, we go with it. In objective, they have to specify because they are asking specific possibility. When we have that multiple ways to implement, they have to ask a specific order. So if I use A and B as select lines, if I use A, B as select lines, let us see what happens. S1, S0, S1, S0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 1. Or we can say that S1 is not connected to AB. Here it is A bar, B bar, A bar, B, A, B bar, A, B. And here it is I0, I1, I2, I3. What else we have here? CD 0, 0, C bar, D bar. C bar, D, CD 0, 1. CD bar, CD 1, 0. CD, CD 1, 1. Right? If ABCD order I have used here, same order I am using to write input combination numbers 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 2, 0, 0, 1, 1, 3, next 4, 5, 6, 7, 8, 9, 10, 11. Right, next 12, 13, 14, and 15. Right? Then what is the min-term specified? 1, 2, 3, 4, 7, 8, 9, 10, 12, 13, 15. Right? Let me write expression. What about I naught C bar D plus CD bar plus CD? See, C bar D plus CD bar plus CD. If I take C common in this, D bar plus D. If I take D common in this, C bar plus C. Then what we get here? D plus C, which is C plus D. Or A simple way we can use C bar D plus CD bar plus CD. In these, C is repeated, D is repeated, C plus D. Simple way is the terms which are rounded up in that C is repeated, D is repeated, C plus D. Or why these are rounded up? Because these are min terms. Which are those? CD01, CD10, CD11 are min terms. That means CD00 is max term. CD00 is max term means what is max term expression? C plus D. Two ways. Simply we can write when three terms are rounded off, we can observe which are the literals are getting repeated. C is repeated, D is repeated, C plus D. Which is not rounded off because it is max term. That means CD00 is not rounded off. It is max term, which is C plus D. And here C bar D bar plus CD, which is C XNOR D. And what about this? I2. C bar is repeated, D bar is repeated. Or CD11 is not rounded off. CD11 is not rounded off. That means C bar plus D bar, max term, right? CD11 is not rounded off. That means it is C bar plus D bar. Am I right? CD11 is not rounded off. CD11 is max term. That is C bar plus D bar. What about I3? CD10 is not rounded off. That is C bar plus D. If anyone has any questions in writing expressions, please let me know. First one is C plus D because CD00 is not rounded off. C plus D max term. C bar D bar plus CD means C XNOR D. Here CD11 is not rounded. Three are rounded off. Observing rounded off terms is C bar is repeated, D bar is repeated. Or as CD11 is not rounded off in this column, so it is C bar plus D bar is max term. Another way, because writing SOP minimizing, writing POS, both are giving same functionality. So what we have done in the first column, writing SOP minimizing, getting C plus D, writing max term by observing which are not rounded off. And what about the I3 column? What about I3 column? Only CD10 is not rounded off. So C bar plus D. Or these two and this one, if you are observing, C bar is repeated, D is repeated. These three terms, if you are observing, first, second, and fourth. So in this C bar is repeated. From these two, D is repeated. C bar plus D. Your wish. What you are going to use. So completing the implementation. OR gate with CD. XNOR gate with CD. Now NAND gate with CD. What we get here? NAND gate with C D bar. C D bar 4 bar. C bar plus D. Yes. Please complete two more. Right? Two more. What is it here? The same function with the S1, S0, CD. What is the inputs we get? Zero, 1, 2, 3. And one more. Same function S1, S0 connected to AC. AC, what will be I0, I1, I2, I3. So complete these two. One is CD as select lines, other one is AC as select line. Complete these two. And meanwhile, we take a small break. We continue after the break. Yes, welcome back. So let us complete this implementation first. Then we go with the last one. S1, S not connected to CD. And here we can use A bar, B bar, A bar, B, A, B bar, A, B. 0, 0, 0, 1, 1, 0, 1, 1. And here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 14, 15. Then what we get expressions for I0, I1, I2, I3. First round of 1, 2, 3, 4, 7, 8, 9, 10, 12, 13, 15. 12, 13, 15. Then what we get here? It is A plus B, and here it is A plus B bar, and here it is B bar is repeated, so it is B bar. Right, here it is A plus, sorry, A bar plus B. Right. So I'm writing just expressions here. You can use logic gates to implement this. A plus B bar, B bar, A bar plus B. That everyone might have done correctly. Now, coming to this one, S1, S0, right? 0, 0, 0, 1, 1, 0, 1, 1, I0, I1, I2, I3 are connected to AC. Here it is now B bar, D bar, 0, 0, B bar, D, 0, 1, B, D bar, 1, 0, B, D, 1, 1. If you write combination numbers, here it is 0, here it is 2, here it is 8, here it is 1, 0, 1, 0, it is 10. Then here it is 1, 3, 9, 11. Next, 4, 6, 12, 14, 5, 7, 13, 15. Then round of given midterm numbers 1, 2, 3, 4, 7, 8, 9, 10, 12, 13, 15. If you are observing, here it is B XOR D, and here it is B bar plus D. Here it is 1, here it is B XOR D. Just I am writing expressions B XOR D, B bar plus D, 1, B XOR D. This is one way we have been getting questions, sir. They may be asking what is that I0, I1, I2, I3, you need to specify. What is I0, I1, I2, I3, you need to specify. Anand, it is correct? Yes, it is correct. Second possible way we have been getting questions on multiplexers is by giving multiplexer circuit, they are asking what is the minterms of the function, what is maximums of the function, what is the minimal expression SOP, what is minimal expression POS. These type of questions we have been getting frequently in competitive exams. By giving multiplexer circuit, they are asking what is the output function, minterms, maxterms, SOP minimal, POS minimal expressions they have been asking. So let us see how can we get questions. Question is, listen, find minimal expression of function f of a comma b comma c comma d implemented by following Mux circuit. in SOP and POS. SOP and POS. The circuit is like this. Find minimal expression of function f of a comma b comma c comma d implemented by following multiplexer circuit in SOP as well as POS. They are giving options. We have to choose the correct answer. First, simple way is finding minterms and maximums using the table method we are using. So when it is rounded off, we have written expressions. When we know expressions, we need to do reverse process rounding off. When it is given rounded off or minterms, we are writing expression in the previous examples. When it is minterms are given, we are rounding off, we are writing expression. When we know expression, we need to do reverse process, rounding off. Let us see how is it possible. So here S1, S0, 0, 0, 0, 1, 1, 0, 1, 1. And also I0, I1, I2, I3. S1, S0 connected to AB. And also here C bar, D bar, C bar, D, C, D bar, CD. 0, 0, 0, 1, 1, 0, 1, 1. If I write combination number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 14, 15. Now, what is I0 connected to? C plus D. It is not C plus D bar. It is possible to give in reverse order also. Observe correctly. I0 is C plus D. I0 is not C plus D bar. There is a possibility for doing mistake. Check it correctly. There is a possibility for doing mistake if you are using order from top to bottom. So it is not a default, it is not a rule to follow top to bottom I0 to I3. It may be given in reverse order also. It is already given in the exams. So it is C plus D. I0 is C plus D means these three must be there. Because CD00 is, according to the expression, what is it here? CD00 is max term, C plus D. What about I1 is 1? That means all these are min terms. I2 is D bar. Wherever D bar is there, there you need to round off. It is D bar. What about I3? C plus D bar. That means CD 01 should not be rounded off. That's it. Nothing great in that. Very simple. Once you are getting min terms, remaining are max terms, use K-map. That you can complete it. Proceed to complete a minimal expression of this function. What is the function we are getting? F of A comma B comma C comma D equals to sigma M of 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 14, 15. 12, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 14, 15. Also can be expressed as pi m of numbers 0, next what? 9, 11, 13. You can use min terms to find minimal expression SOP. You can use max terms to find minimal expression POS. Complete that. Everyone should try. Complete this minimal expression. Use K-map to find minimal expression. What are the min terms? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Next. Next. 8, 10, 12, 14, 15. 8, 10, 12, 14, 15. 8, 10, 12, 14, 15. Find minimal expression in SOP as well as PYS. One, 2, 3, 4, 5, 6, 7. I think I have chosen correctly. 8, 10, 12, 14, 15. 8, 10, 12, 14, 15. Right, let us see groupings. This is one grouping. This is one more grouping. This is another grouping. Right. So here we have one more grouping. Here we have another grouping. Here we have one more grouping. And also here we have. Can you guess how many prime implicants have grouped in this? Please respond. How many prime implicants have grouped in this? Yeah, Karthik, that much don't expect. Maybe given for 2 marks itself, not 10 marks. So how it will be 10 marks, I'll show you that. Already given in the exam on propagation delay. I will show you the questions. How many prime implicants we have in this, in which I have grouped? Check, count it correctly. How many prime implicants are there? Still people are doing mistakes on prime implicants. Number of prime implicants I have grouped. Count correctly. Prime implicants I'm asking, not essential prime implicants. Number of prime implicants I'm talking. I have grouped already, just count. You don't need to group. Don't say your answers, please. Count in my grouping. All the prime implicants already have grouped. Count those and let me know how many prime implicants we have. Let me do that. See, listen carefully. This is one prime implicant. This is one prime implicant. First one. Next, second prime implicant. Then third prime implicant. Fourth prime implicant. Fifth prime implicant. Sixth prime implicant. Seventh prime implicant. Total 7 quads we have, which are prime implicants. Don't do any mistakes in this. Count it correctly. Prime implicants are 7. Count correctly. Some people are doing still mistakes. Manikanta Choni. Count groupings. See, once again I'm doing 1, 2, 3, 4, 5, 6, 7. Total prime implicants is 7. In these, how many are essential? How many groupings are essential? Please respond. How many essential prime implicants? How many essential prime implicants? Yes. Most of you are answering correctly. Okay. So some are doing mistakes, sir. Yes, very good, very good. Okay, stop responding. Let us see. Let us see. Yes. In this we have a special cube. In this we have a special cube. So essential. In this we have a special cube. Essential. In this grouping we have a special cube. Essential. Then again, in this group we have a special cube. Essential. Right? This grouping is having special cube. Essential. This grouping is having special cube. Essential. This grouping is having special cube. Essential. Finally, 3 essential prime implicants. No more groupings are having special cubes except 3. Let us specify. So this is essential, right? This is essential and this is essential. There is speciality for this question. Listen carefully. How many essential prime implicants? 3 essential prime implicants. In this grouping we have special cube. In this grouping we have special cube. In this grouping we have special cube. So these 3 are essentials. First let me write essentials. This grouping is A bar D. This grouping is what? B C. This grouping is what? A D bar plus. Now, how many minterms are not covered by essentials? This is one, this is second one. This is one, this second one. These 2 minterms are not covered by essential prime implicants. These 2 minterms are not covered by essential prime implicants. Then to cover this, what is it here? This is one possibility. This is second possibility. Check it correctly. To cover this minterm, we have this quad A bar B, this quad B D bar. Cost is same. I can use any one. To cover this one minterm, here this is one possibility A bar B, this another possibility B D bar. And after that, this minterm also not covered by essential. To cover this minterm, again we have a vertically quad C D bar, and again it's a quad A bar C. It is A bar C, and this one is C D bar. So to cover this minterm, again this possibility is there and another possibility is there. We have again 2 possibilities. So to cover this minterm, 2 possibilities. To cover this minterm, again 2 possibilities. Right? By this time you might have understood what I'm going to do. To cover this minterm, let me choose horizontally A bar B. To cover this minterm, let me choose this vertical one C D bar. Or to cover this minterm, let me take a horizontal A bar B only. But to cover this minterm, let me choose this one. Instead of this one, I'm choosing this one because both are having same complexity. What is here? A bar C. Or why should I choose A bar B only for this? I can choose this one also. I can choose this one also. What is this here? It is B D bar. Plus to cover this one, C D bar. Or to cover this minterm, let me choose B D bar only. Plus to cover this one, I'm choosing A bar C. All these 4 expressions are having same complexity. I told you there are questions with 4 minimal expressions also. Then I said, I don't want to saturate you now. I will give you later. So this is a question which is having 4 minimal expressions with same complexity. See, to cover this one minterm, we have this possibility as well as this possibility. To cover this minterm, this possibility as well as this possibility. Total, to cover these 2 possibilities, to cover these 2 possibilities, total 4 possibilities to cover those 2. Finally, 4 minimal expressions. If anyone has any questions, let me go with your questions. Yes. Prime implicants is 7. The essential prime implicants is 3. Essential prime implicants are not covering 2 minterms. Each minterm is having 2 possibilities with the same complexity. Then finally 4 combinations we are choosing each min term. So finally, what is here for these two possibilities? For the this one also two possibilities. So finally, four possible ways we can cover those two min terms with same complexity. Finally, four minimal expressions. मजा आ रहा है? मजा आ रहा है? हाँ? That is the digital circuits. What we know is not sufficient for competitive exams. What way we can get questions? By giving this function, the number of minimal expressions of this function in SOP, the number of minimal expression of function f of a comma b comma c comma d in SOP. In SOP, they won't give you all these answers. Or advantage here is I can frame these four, I can give four options because multiple select questions nowadays, right? We are getting multiple select questions. In that, I can give these four options. Right? With respect to multiple select question, they can play in digital like anything. Please take my words in a positive way because it is before exam, right? Before exam, so we need to concentrate on subject in depth, right? So as we are preparing for exam, let us prepare in depth. Then we can do or not in the exam, we see later. But while preparing, let us give our best. So here they can frame a question like a numerical answer question. The number of minimal expressions of function dash, or in multiple select questions, they can give four options, four different answers. But these four are correct. Am I right? Are you there? So that is the depth of the questions we can get. In-depth questions. Right? If you are interested, I'm ready to cover that levels. The only thing is, I must observe you are interested. If any questions can be like this. By giving minimal expression of the function f of a comma b comma c comma d, these numbers may be given. Then options may be given: first option, second option, third option, fourth option. These four are correct. I have to choose a 1, 2, 3, 4. I need to select all four. Then only we are getting, if it is 2 marks question, we are getting 2 marks. Other possibility, what is it here? Numerical answer question. What is it here? You need to enter the number. Right? There, what they can ask questions is the number of minimal expressions of function f of a comma b comma c comma d. They are giving these numbers in SOP is dash. Sanjeev, wait. Sanjeev, please wait. They can frame questions like that, like multiple select questions or numerical answer question, or there may be only one option also correct. Such questions also may be given. The number of minimal expressions, then they may be giving options 1, 2, 3, 4. Right? 1, 2, 3, 4. With a little bit knowledge, what we think that minimal means final. Final, how can we get many? It can be only one, right? General opinion, we had that. But after this discussion, you might have observed minimal expression can be multiple also. Right? So, if you're having that opinion, minimal can be only one. Where can we have multiple minimal? Only one minimal if you are saying that option is waiting for you. Sir, madams, right? Are you understanding? If anyone has any doubts, I'll go with your doubts. Right. Generally, people think that digital is easy. Easy if I don't discuss anything. Easy if I don't discuss to the level which they are expecting in the competitive exams. I can show you that nothing is there in digital that I can complete in 2 days for information. So people think that digital is easy. Not easy if you are not understanding in depth. Yes, let us understand in depth and it is easy to score maximum or 100%. Yes, that's what I'm saying. Why people have been raising hands? Sanjeev, wait, I will discuss your doubts at the end. Sanjeev RP. Right. Okay, let me find minimal expression of the function in POS. In POS. This is one grouping, second grouping, and third grouping. I'm writing POS directly. So A plus B plus C plus D. Then here what we have? A bar. I hope everyone is able to write C plus D bar. Another way is A bar plus B and A bar plus B plus D bar. Am I right? A bar plus B plus D bar. POS. POS minimal. Right. Very good. Very good, Anand. So many concepts are waiting for you, right? In sequential also. Right? Same question is same. Find a minimal expression of the function f of a comma b comma c comma d implemented by following multiplexer circuit in SOP and POS. Please complete that. First find input expressions, then find minterms and maximum, then use K-map. Then find minimal expression in SOP and POS. Anusha, please wait. If any issue is there, please mention in the chat box. I'll be checking. Okay, no problem. No issues, Sanjeev. I need to say sorry. Right. What is expressions? What is I naught? A plus B. What we get here? 0. What we get here? 1. Because the XOR gate, two inputs are same. Output is 1, output is 0. When two inputs are unequal, output is 1. Two inputs are equal, output is 0. Then NAND gate, one input is 0, output is 1. XNOR gate, two inputs are same. Here it is 1. XOR gate, one input is 1, output is B bar. And what about this? It is A XOR B. And again XORing with AB, also known as A plus B. If you remember the properties we have discussed. Am I right? Right. Correct. Okay. Yeah, Toy Akshudu, you did a mistake. Check it. That I discussed as a property and mentioning one ESC question also. Now, let us use the method we are using to find minterms and maxterms. S1, S0, 0, 0, 0, 1, 1, 0, 1, 1. And here I0, I1, I2, I3. What is the S1, S0 connected to? DC. Don't use CD. You might have done a mistake. S1, S0 connected to DC. It is not CD. Outside it looks like CD, but inside it is not S1, S0. It is S0, S1. When S1, S0, if it is observed, it is DC. Then what else is there? Here it is A bar, B bar, 0, 0. A bar B, 0, 1. A B bar, 1, 0. A B, 1, 1. Then what we have here? 0. It is not 1, it is 2 now. Then 1, 3. Next 4, 6, 5, 7, 8, 10, 9, 11, 12, 14, 13, 15. 13, 15. Right? Now, what is I naught? A plus B. Round off. A plus B. What about I1? 1. All these are minterms. What about I2? B bar. B bar means A bar, B bar, A, B bar. What about I3? Again, A plus B. Right? Now, f of A comma, B comma, C comma, D equals to sigma m of what we are getting? 1, 2, 4, 6, 7, 8, 9, 10, 11, 12, 14, 15. That you can do minimization, very simple. Is equals to pi m of 0, 3, 5, 13. Complete that minimization. Leaving it to you. I'm not doing this minimization, very simple. Not like a previous one. You can do that. Right. If you need any help in solving this question, let me know. Minimization very simple, not a very big one. Yeah, I think Sitaram, you would have observed what is the mistake you have done? Yeah, Triveni. Here XOR, both the inputs are A. What will be the XOR output? When two inputs are equal, output is 0. When two inputs are unequal, output is 1. That is XOR function. Coming to XNOR. Coming to XNOR. When two inputs are same, coinciding, equal, output is 1. Otherwise, output is 0. See, if you are using CD, it will be wrong. Internally, if you are observing S1, S0, it is connected to D and C. Don't use CD. If you are using CD, you would have gotten here 0, 1, 2, 3, 4, 5, 6, 7, and so and so. But it is a DC. Then go with the new order. A, B, C, D, we are using numbers. But here it is used S1, S0, DC. Then these two columns will be interchanging. I1, I2 will be interchanging. Check it correctly. Sahil Singh. Sahil Singh. Yes, that's what I've been saying. That's what I've been saying, Sitaram. Yes. See, generally what we think, we understood everything. They are finding the ways where there is a possibility for doing mistakes. That's what I say always. These competitive exams are not checking our knowledge. They are trying to bluff us. It's a bluffing game. Don't get bluffed. They're trapping you. Don't get trapped. Then we can win this race. Otherwise, you are getting trapped. Don't get trapped. Observe how it is mentioned or what is given there. What they are asking exactly. If you're understanding this, nothing is there in competitive exams. Because everyone, thousands have been taking coaching. Thousands of people have been taking coaching. Very few have been focusing on that. And some people have been concluding, yes, I understood. No. Even though you understood, spend your effective time maybe looking at that question in a different way. Right? Even though you have solved that question already, please go through that question once again. You may be getting another idea, or you may be understanding that question in better way, or you may be observing where they can change the question on yourself. Instead of waiting for exam, you can check where there is a possibility for changing the question. Looks like same, but there may be possibility for doing mistakes. If small change is there in the question, there is a possibility for doing mistakes. Take these words in a positive way. I don't want to discourage you, but I want to educate you towards competitive exams. I'm trying to educate you. I'm not discouraging you. If you are getting discouraged now, I can stop my words, but sure, you will be disappointed after exam. Getting discouraged, not a problem. When you're getting discouraged, you may be finding where there's a possibility, other possible ways. But if you are getting disappointed after result, it is not a good thing. Okay, I may be discouraging you. I feel that I'm educating you, but you may be thinking that I'm discouraging you. Okay, not a problem. If you're getting discouraged now, after at least 1 hour, you may think that, oh, he was saying something, let me think in another way. Somehow you will be changing your way of thinking. Right? Your perception may be changing about my words after 1 hour or 1 day. But my intention is you should not get disappointed. Right? Please understand subject in depth. Instead of expecting it is easy. Not only digital, every subject has its own depth. And if I make it easy, means I'm not covering in depth. Any subject. Even if I consider a linear algebra also has its own like levels. I'm not saying that the subject is easy, but I'm saying simple mathematics subject also. There may be right next levels of questions. So please, every subject you need to spend effective time, understand the concepts correctly, and find your own mistakes. I am showing that where there is a possibility for doing mistakes, common mistakes, how they can frame the questions by observing the questions already given. I've been giving this information, but still you may be having your own mistakes. Find your own mistakes and correct those mistakes before going to final exam. Then obviously you will be winning this race. Please understand these words in a right way, because still time is there. Still time is there. Now, if you are realizing, then in this time you can utilize in right way. This coaching also can utilize in right way. Otherwise, even I show you that it is very simple. Nothing is there. If nothing is there, what is the need of coaching? In a subject, if nothing is there, what is the need of coaching? With simple concepts, simple formulas, we are not able to succeed. That means there is something is there in each and every subject. We need to understand that. For that only we are in coaching. So let us utilize this coaching for our better future. Is only one. Yes. Yes, sir. I don't remember answer. Everyone can do. Everyone can do. It is a easy question only with respect to minimization. Again, some next level of question. By this time, you might have understood what we need to do. By knowing that input expressions, to implement all those input expressions, how many two input NAND gates required? That's what we need to complete. Right. Now let us see, first of all, what is input expression, sir? Then we see how it can be implemented using. Let us see what is the input expression, sir? 0, 0, 0, 1, 1, 0, 1, 1. S1, S0 connected to AB. Here it is I0, I1, I2, I3. And here it is C bar, D bar, 0, 0, C bar D, 0, 1, C D bar, 1, 0, C D, 1, 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right. Now, a round of given minterms 1, 2, 4, 5, 7, 9, 12, 15. Help me in writing expressions. Here it is C XOR D, and here it is C bar plus D, and here it is C bar D, here it is C XOR D. Let us implement all these using only two input NAND gates. Only two input NAND gates. Right. Let us see how it can be implemented. C XOR D, C bar plus D, C bar D, C XOR D. So C XOR D using NAND gates. Already we know NAND gate implementation of XOR, right? I hope no one is having any doubt about this, sir. Here we get a C XOR D, right? Now, what else is required? C bar plus D, C bar D. If you are observing, here it is a CD whole bar. Here what we get? I am writing expression of this C CD bar whole bar is nothing but C bar plus CD is nothing but C bar plus C and with C bar plus D. So here we are getting C bar plus D. Any questions? Check it correctly. Here CD bar. Here again C CD bar whole bar. That's what I'm writing. So expanding C bar plus CD. C bar plus D is nothing but C bar plus D. Here we are getting C bar plus D. Can you guess what can be here? C plus D bar. C plus D bar. Am I right? Check it. D C D bar whole bar. D C D bar whole bar. So then D bar plus CD. That is nothing but C plus D bar. Now you can understand. So what about I1? C bar plus D. Do I need to use additional logic gates? No. It is already there. What about third one? C bar D is nothing but C plus D bar whole bar. Let me use one NAND gate as inverter. Right? C plus D bar whole bar is C bar D. What about last one? C XOR D is nothing but using another NAND. What is the answer? What is the answer? 6. 6 number of two input NAND gates required. If anyone has any questions, let me know. Don't get saturated, please. Suggesting you accept the concepts, accept the level of questions we can get, because it is covering most of the topics so far we have discussed. Logic gates, Boolean expressions, right? All those it is covering. If you are having any doubts, please let me know. I will help you. Suggesting you don't get saturated. Otherwise, I will skip this type of questions because I want to revise the concepts. Long logic gates, long back we have studied. You may be forgetting those, right? No, you should not forget. Right. Done? Any doubts? Any doubts? Mostly we have been getting 2 marks question from this topic multiplexer. Maybe getting any question, maybe covering any topic in this. They may be asking you to implement, they may be asking to find expression, they may be giving function implemented, they may be asking you to analyze. So you may get any question. So you must be in a position to answer any question. That's what my intention. I'm trying my level best, all possible ways where we can get questions, right? I would like to know how many of you are feeling like, is it required to know this much like that? I know, because some students who are approaching me when it is offline classes, people were approaching me and asking, is it required this much? But my intention is not to waste your time. If you get that question, sir, right? Yes, I do. Even though you are getting saturated, I won't leave you. Because top 10 students only. I know that top 10 is 10 students only. If you're having that capability, if you're having that interest, you should not lose that possibility. That's what my intention. Yes. If anyone is feeling like saturated or right. Okay. Good. Manikanta Choni. Good. తెలుగు సినిమా డైలాగులు బాగానే ఉంటాయి. దేనికి పనికిరావు, జాగ్రత్త. వాళ్ళు బతకడానికి మనల్ని ఎమోషనల్ గా ఫీల్ చేస్తారు తప్ప దేనికి పనికిరావు. మణికంఠ చోని. But what can we do, Ashutosh? It's not in our hands. Okay. Yes. Okay. Thank you for your interest. No. No, Sampath. Try. Sampath. Please try. It won't be. The only thing is XNOR using NAND gates means including this NAND gate we are getting here. Then in between we are connecting here. Same thing. Just it is moving here. Sampath. Yes, I'm trying my level best. Okay. Active region. of which device? Anand. Active region of BJT, saturation region of MOSFET. Where we can have gain. Anand. Okay. Very good interest. I've been observing in students, which is motivating me to do more. Right, fine. With the same interest and enthusiasm, let us get into next topic, demultiplexer. Which is a demux. A simple device. Very rarely we have been getting questions because not feasible to frame questions, different questions in this. But very rarely we have been getting questions. So let us understand correctly demultiplexer also. Don't worry, Ashutosh. You may be getting another chance if you request the team. You will be getting chance to attend again and again, not a problem. And the advantage of this online is they are providing the videos also. You have a chance to, right, go through that 3 times is a possibility. So don't worry, all the concepts, right, you can understand from that recorded videos. Yes, Sai Kumar. I will discuss that questions, including propagation delay. Yes. Will be provided, Bhaskar will be provided. Yes, Sai Kumar, it is possible. It is already given. I'll show you that how we are getting questions, including propagation delay. Okay, that's a problem. Right, whichever is possible, minimization, you need to do that. Right. What do you expect, Ashish? Shall we? Right. Demultiplexer, which we name it as demux. Right. What is its functionality? Already we have discussed one input, multiple outputs. One input, multiple outputs. Here we have one input, multiple outputs. And also 1 to 2 power n or 1 is to 2 power n. We name it as a demux. If I say I, here we can have y naught, y1, so and so, y to power n minus. For this, we need n select lines. N select lines. What is it here? Input data will be transferred to one of these 2 power n output lines based on this n select lines. Already we discussed the basic functionality of demultiplexer. Clearly, already we have discussed. So once again, I'm mentioning here the data available on input line that I will be transferred to one of these 2 power n output lines based on this n select lines. Similarly, what is it here? The switch connecting this one input to one of these 2 power n output lines based on this control signals. Based on this control signals. If I say that 1 is to 2 demux. 1 is to 2 demux. What we can say here? 1 input, 2 outputs. How many select lines, sir? One select line. If I say here y naught and y1, what is its functionality? We can understand that. When s equal to 0, I is transferred to y naught. When s equals to 1, I is transferred to y1. Once again, its functionality is When S equal to 0, I is transferred to Y0. When S equals to 1, I is transferred to Y1. Then what will be the output? S bar and I, here it is S into I. Understand correctly? When S equal to 0, I should be available on Y0. So if I substitute S equal to 0, 0 bar and with I, 0 bar is what? 1. 1 and I, it is I. Y0 is I when S equal to 0. When S equal to 0, what about Y1? 0 and I, whatever is that input data, Y1 will be 0 when S equal to 0. When S equal to 0, the I will be transferred to Y0, Y1 is 0. When S equals to 1, when S equals to 1, 1 bar and I, 1 bar is 0, 0 and I is 0, and 1 and I, it is a I. So I will be transferred to Y1 and Y0 will be 0 when S equals to 1. Finally, what is it here? When S equal to 0, Y0 is I, Y1 is 0. When S equals to 1, Y0 is 0, Y1 is I. Y1 is I. So it is satisfying expanded functionality. And if you are observing, implementation also we can do S bar and I, S and I. Here it is Y0, Y1, Y0, S bar and I, S and I. Right. Now, if it is a 1:4 demultiplexer, 1:4 demultiplexer, then what we can have here? One input, four output lines. One input is I. If I take a S1, S0, and here we can have like this. Let me say it is Y0, Y1, Y2, Y3. Instead of mentioning numbers and again Y0, Y1, Y2, Y3, I'm writing this Y subscript number with the select line combination. So for 0, 0, Y0, 0, 1, Y1, 1, 0, Y2, 1, 1, Y3. It is 1:4 demux. Then what is it here? When S1, S0 is 0, 0, I should be transferred to Y0. Means what is the Y0 expression? S1 bar, S0 bar, I. What about Y1? S1 bar, S0, I. What about Y2? S1, S0 bar, I. What about Y3? S1, S0, I. S1, S0, I. S1, S1 bar, S0, S0 bar, and also input data I. Not required. Simply I'm giving the inputs also. You can imagine how it can be implemented also. Y0, Y1, Y2, Y3. S1 bar, S0 bar, and I. S1 bar, S0, I. S1, S0 bar, I. S1, S0, I. These are outputs. Moving to next slide. One is to 8 demultiplexer or 1 to 8 demux. Here it is I. There are 8 outputs. One is to 8 demux. Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. And how many select lines? 3 select lines, S2, S1, S0. Then let us see what is that output expressions. When S2, S1, S0 is 0, 0, 0, I will be transferred to Y0. That means S2 bar, S1 bar, S0 bar, I. And again, what about Y1? S2 bar, S1 bar, S0, I, because 0, 0, 1. Next, S2 bar, S1, S0 bar, I2. Next, S2 bar, S1, S0, I3. S2, S1 bar, S0 bar, I4. S2, S1 bar, S0, I5. S2, S1, S0 bar, I6. S2, S1, S0, I7. No need to implement, you can understand how it can be implemented. S2, S2 bar, S1, S1 bar, and S0, S0 bar, and using I also, we can use 8 number of 4 input and negates. We can implement expected Y0, Y1, Y2, Y3, so and so, Y7, so and so, Y7. Right now, now, any questions? I'm feeling a little bit tired today. So let me wind up here for today. If you have any questions, you can raise the hands. We'll go with your doubts. If you don't have any doubts, you can leave the meeting. Chakravarti.
Hello, sir.
Yes, Chakravarti.
Sir, can you 24, sir? 24 slide.
Okay, 24.
Sir, here we have seen that in the second column, if you see, you have taken.
Second row, right?
Yeah.
First two plus two.
Yeah. So if you go to the third column, you have taken that C bar plus C is 1, right?
Yeah.
So suppose the question was function of max terms.
If it is given max terms, remember this. If it is given max terms,
Yes.
as the function we are analyzing,
Yes.
what is the multiplexer output expression we are using? SOP.
Yes, sir.
When max terms are given, convert it to min terms expression.
Okay, sir. So, sir, suppose if it is like the number of max terms is less, and then if we convert it to min terms.
Even better to go with the min terms.
Okay, sir.
When
So
you
it's
are analyzing max terms or min terms, finally the implementation will be same because the multiplexer function is deciding what we get inputs here.
yes, sir.
Right.
So it's basically like if the function is given as max term, also we convert to min term, and
Convert to
then
min term because the multiplexer output expression, whatever we are writing, S2 bar, S1 bar, S0 bar, I0 product
yes,
term
yes,
plus
yes,
S2 bar,
yes, yes,
S1 bar, S0, I1, so and
yes,
so.
yes. Okay, sir.
We are analyzing multiplexer with the SOP.
Okay, sir.
Right.
Thank you, sir.
Uju Manikanta.
Sir,
Manikanta.
good
Yes.
evening, sir.
Which one?
Hello.
Yes, Manikanta. Tell me.
Good evening, sir.
Very good evening, Manikanta. Tell me, what is your doubt?
Same slide, sir.
Yes.
If the output of mux is asked in the wrong sequence, what we have to do, sir?
Function is given in this order, and here it is
ABCD and the
asking.
output is asked in ADB or something. He interchanged the variables.
So they won't ask you the different order. Here they can change the order.
Okay, sir.
Right? So whenever they are specifying here, they have to specify the same. But here they can use any of the variables, any of the order.
Okay, sir.
That doesn't
Thank you,
matter
sir.
if you are changing the order of the variables.
Okay, sir. Thank you, sir.
Right. Kumar Maddi.
Hello,
Yes, Kumar.
sir. If you don't mind, please open slide number 14, 15, 16. Shall I
I
take
don't
a
have anything to mind. I'm there to help you. Yes, tell me.
slide number 4? Sir.
It's 14
Okay.
only.
Sir, 15. Just I will take screenshot, sir. No
Okay.
doubt here.
Okay. 14,
Okay, sir.
15, 16.
Okay, sir. Thank you, sir.
Thank you. Yugashri.
Good evening, sir.
Very good evening, ma. Tell me.
Sir, 24F, can you?
Yes. Yes.
Sir, in that, if the one, ఒక్కటే మనం రౌండ్ ఆఫ్ చేసాం కదా సార్, అంటే గివెన్ డేటాలో
ఒక కాలంలో ఒకటే రౌండ్ ఆఫ్ చేసాం.
అయితే
First one.
కింద సి లో ఉన్నందుకు సి
పెడతాం.
సి
C
బార్
bar
లో
అంటే C bar.
ఇది
రౌండ్ ఆఫ్ ఉంటే 1 పెడతాం.
సార్ ఇంతకు ముందు ప్రీవియస్ లాస్ట్ చెప్పారు కదా సార్, డి మ్యాక్స్ ముందు
డిమాక్స్ కు ముందు ఏం చెప్పాను?
ముందు సార్ అదే
ఇదేనా?
అదే సార్. సార్ మనం 9 కి ఒకటే రౌండ్ అప్ చేసాం కదా సార్, ఆ కాలం లో
ఈ బాడీ రాస్తాం. ఇంకేంటి?
అంటే మనం సి బార్ డి ఉంది కదా సార్ అక్కడ.
అవును. ఇప్పుడు
అప్పుడు
ఒకటి వేరియబుల్, ఇప్పుడు 2 వేరియబుల్స్ ఉన్నాయి కదా.
ఓకే.
ఏదైతే రౌండ్ ఆఫ్ అయిందో అది 2 రౌండ్ ఆఫ్ అయితే రెండింటి ప్లస్ సి బార్ డి ప్లస్ సిడి బార్, అందుకని ఎగ్జామ్ అన్నాం.
అంటే అక్కడికి ఇక్కడికి డిఫరెన్స్ ఉంది కదా సార్, అప్పుడు ఇక్కడ ఇలా
ఒకటే వేరియబుల్ కాబట్టి ఓన్లీ సి బార్ ఉంటే సి బార్ పెట్టాము, ఓన్లీ సి ఉంటే సి పెట్టాము. కానీ ఇక్కడ టర్మ్ ఏంటి? ఇప్పుడు సి బార్ డి, సి బార్ డి రాస్తాం. అలాగే 2 రౌండ్ ఆఫ్ చేసినప్పుడు ఏం చెప్తాము? సి బార్ డి ప్లస్ సిడి బార్ ఏమవుతుంది? సి ఎగ్జాక్ట్ డి అవుతుంది. అంతే కదా. ఇప్పుడు ఈ 2 ఉన్నాయి అనుకో, ఏం చేసాం ఇక్కడ? సి బార్ డి బార్ ప్లస్ సిడి, దాన్ని ఏమన్నాం? సి ఎక్స్ నాట్ డి అన్నాం కదా. అంతేనా?
1 రాసుకున్నారు కదా సార్ ఫస్ట్ లో.
ఎక్కడమ్మా? ఇక్కడ ఇప్పుడు అన్ని రౌండ్ ఆఫ్ అయి ఉంటే అప్పుడు 1 అవుతుంది. ఎక్కడంటే చూపిస్తాను. ఇక్కడ ఇదేనా మీరు చెప్పేది? ఇక్కడ అన్ని రౌండ్ ఆఫ్ అయి ఉన్నాయి, అప్పుడు మాత్రం 1 చెప్తాను. అంటే ఏబి 0 0 0 1 1 0 1 1 అంటే ఏబి మీద డిపెండ్ అవ్వట్లా. అంటే ఏబి ఏమున్నా కూడా అది 1 అవుతుంది. అప్పుడు ఏమవుతుంది? ఏబి మీద డిపెండ్ అవ్వట్లేదు. మనకు ఆల్రెడీ తెలిసిందే, 2 వేరియబుల్స్ ఆర్ ఎగ్జిస్టింగ్ ఇన్ 2 power 2 కాంబినేషన్, దట్ మీన్స్ 2 వేరియబుల్స్ కంబైన్లీ కెన్ బి ఎలిమినేటెడ్. 2 వేరియబుల్ కే మ్యాప్ తీసుకున్నప్పుడు ఏం చెప్పాము? ఒకవేళ క్వాడ్ కనుక అయితే అన్ని కాంబినేషన్స్ కనుక ఫంక్షన్ 1 అయితే ఏం చేస్తాము? క్వాడ్ ఏ ఎలిమినేటెడ్ బి ఎలిమినేటెడ్, అప్పుడు ఏం చెప్తాము? 1 అన్నాం కదా. అలాగే ఇది కూడా.
ఓకే సార్. ఓకే సార్.
థ్యాంక్ యూ.
సార్ మీరు మార్నింగ్ హవర్ లో తీసుకోవచ్చు కదా సార్ క్లాస్?
అది డిపెండ్స్ అమ్మా. ఏంటంటే కాంబినేషన్స్ ఉన్నాయి. అంటే ఎలక్ట్రికల్ సెపరేట్ గా, ఈసీ సెపరేట్ గా, కొన్ని మార్నింగ్ బ్యాచెస్ లో మార్నింగ్ లో కొన్ని క్లాస్ అవుతున్నాయి. ఆ కాంబినేషన్స్ అందరికి కలిపి నాకు ఇప్పుడు క్లాస్ ఉంటుంది.
ఓకే సార్.
అంటే మార్నింగ్ లో ఒక సెషన్ అవుతుంది కదా, వాళ్ళందరినీ అన్ని బ్యాచెస్ కలుపుకొని ఇప్పుడు ఇది.
ఓకే సార్.
అందుకని ఇలా ప్లాన్ చేశారు.
ఓకే సార్. థ్యాంక్ యూ సార్.
రైట్.
In 24th slide.
Not audible, ma.
In 24th slide, sir.
24th slide. Okay. 24. Okay. Everyone is having doubt in this, right?
No, sir. Here see that here we add like +2, right?
Why it is +2 you are asking?
Yeah.
So in the first row, what we have C equal to 0. In second row, what we have? C equals to 1. Now,
Okay.
so what is the order we are using? A, B, C, D. If I write 2 power 0, 2 power 1, 2 power 2, 2 power 3. A, B, D are same. First row, second row, A, B, D are same. But C equal to 0 first column. Ante, it means 2 is not added, right? in the first row. While calculating combination number, in C position, if you have 0, 2 was not added. In second row, C equals to 1. The difference is only C equals to 1, right? ABD same. Am I right?
Yes, sir.
Right? So, except C equals to 1, difference is not. So, C equals to 1 means what is the weight of C with order 2? That is, 2 was not added in the first row. Now I am adding 2 in the second row. That's it. First
This
row
was-
plus because the remaining A, B, D are same.
This is applicable for all, sir. This logic.
Not audible. Please. What is it?
Logic is applicable for all, sir.
No. In this simply as it was possible, I have taken. Don't go with that logic, please.
Okay.
Right,
Okay,
don't
sir.
go with the
That's
logic.
why I'm thinking, sir. Is
No,
it
no, no.
logic or shortcut method like I'm thinking?
No. Don't use it as a shortcut, please. As I observed, it is C. C position value is, if for example, you have that A, example, A, C, D is there, for example. You are getting first row with the B bar B. Then what should be added to second column? Second row?
Four.
What should be added to the second row?
4, sir.
4. It is 0, 1 because 2 power 2 is the weight. First row plus 4 is giving second row. If you are understanding that, okay. Otherwise, don't use any shortcuts here, please.
Okay, sir. Thank you.
Okay, understood. Right. Okay. Any more doubts? Okay. Sai Pratyush.
Hello, sir.
Sir.
Sir, in 30th slide,
Okay. Here. Okay.
sir, in this, can't I get the Boolean expression directly by C bar D bar into A plus B?
You can write. You can write and expand, make it canonical, get them in terms. You can do. If you're not comfortable with this, I'm comfortable with this.
Okay.
I'm comfortable with this. I felt there won't be possibility for doing mistakes in this because when I'm writing expression, right, D bar, C bar, and with I naught, A plus B, again expanding, again writing the canonical because the variables are missing. We need to consider it is lengthy process.
Again, we have to add some.
Again, we have to add terms which are missing, variables.
Okay.
For example, if you are observing this, what is it here? D bar, C, and with 1. That means A bar, B bar plus A bar, B plus A, B bar plus A, B. You need to understand all this, right? Right? It is a bit difficult to write all those and there is a possibility for doing mistakes.
Okay, sir. Thank you.
Whichever is comfortable, more convenient and less possibility for doing mistakes, I suggest. General.
Okay, sir. Thank you, sir.
Thank you. Yeah.
Hello, sir. Good evening, sir.
Yeah, who is talking?
I'm Pranit, sir.
Who is that?
Hello? Pranit, sir. Pranit.
Pranit, why do you
Yes.
give name with like a Meti 9999? I'm not able to
Okay,
change
okay.
your name if possible.
Okay, I will change it tomorrow, sir.
Pranit, right?
Yes, sir. Yes, sir.
Pranit, okay.
Sir, can you once explain 10:1 mux using 2:1 mux, sir?
Something 2:1, right? Okay.
I think it is 8F or 9F, sir.
Okay, I'll go to
After this, sir. After this.
okay. 9. Okay. What happened?
Sir, once explain that I8 and I9 one, sir.
I8 and I9 are having S3 equals to 1, right?
Yes, sir.
But the differentiation with the S0, right?
Yes, sir.
S0 is 0, I8. S0 is 1, I9. That's what I'm using. S0 is 0, I8. S0 is 1, I9. Those are coming to S3 one line, right? When S3 is 0, upper this 8, depending on S2, S1, S0. This part is what? This part is what? I0 to I7, depending on S2, S1, S0. That is should be the final output when S3 is 0, satisfied. When S3 is 1, we have two possibilities, I8 and I9. These two can be differentiated with the S0. Done now?
Okay. Okay, sir.
Sai Kumar.
సార్
Yes,
సార్
sir.
నాకు సిఆర్పిక్యూస్ ఉన్నాయి కదా సార్,
అవునా?
సిఆర్పిక్యూస్ లో ఒకసారి చూడగలరా సార్ అవి కే మ్యాప్స్ క్వశ్చన్స్?
చెప్తాను, నేనే చెప్తాను, అన్ని చెప్తాను.
ఒకటి రాలేదు సార్, నిన్న మీరు చెప్పారు కదా.
ఏదో చెప్తావా?
6th క్వశ్చన్ సార్, అది నిన్న మీరు చెప్పారు ప్రైమ్ ఇంప్లికెంట్స్ కాదు ఎసెన్షియల్ ప్రైమ్ ఇంప్లికెంట్స్ అని ఎక్స్ప్లెయిన్ చేశారు.
అవును.
ఆ 2 డౌట్స్ వచ్చాయి, ఇది ఆగింది సార్.
అన్ని చెప్తాను. నీకు కావాల్సిన క్వశ్చన్ ఏంటంటే, నాకు తెలిసి 6th క్వశ్చన్ అన్నామంటే నెంబర్ ఆఫ్ మినిటమ్స్.
అవును సార్,
చెప్తాను.
అది మీరు చెప్తారు కదా సార్. అయితే
నేను అన్ని చెప్తాను క్లాస్ లో, ఏది మిస్ అవ్వదు. లాస్ట్ కావాలంటే ఒక క్లాస్ స్పెషల్ గా తీసుకోవాలన్నా నీకున్న డౌట్స్ అని చెప్తాను, సరేనా?
అలాగే
వద్దు. ఒకవేళ నీకు అక్కడికి కాకపోయినా నాకు మెసేజ్ చేయి, వాట్సాప్ చేయి, రైట్? విల్ గెట్ ఇన్ టచ్ విత్ కాల్, నాట్ ఏ ప్రాబ్లం. ఎక్కడ టెన్షన్ తీసుకోకు, ఐఎమ్ దేర్ టు హెల్ప్. అర్థమైనా? ఇప్పుడు అయిపోయింది, పరిగెత్తాల్సిన అవసరం ఏం లేదు, నేను ఉన్నాను. ఎగ్జామ్ వరకు ఉంటాను, రైట్? టెన్షన్ తీసుకోవాల్సిన అవసరం లేదు. ప్రతి క్వశ్చన్ ఎలా అనలైజ్ చేయాలో చెప్తారు.
ఓకే సార్,
టెన్షన్ ఏం లేదు, నేను చెప్తాను, సరేనా?
అలాగే సార్.
ఓకే. Param.
Good evening, sir.
Very good evening, Param.
Sir, 30F slide. Yes.
Okay.
Sir, can you explain once how that A plus B came there?
Here?
Yes. A plus B 1.
You can write A bar B plus AB bar plus AB and simplify.
Okay.
Because these are midterms.
Okay. And if they are asking about max terms, then?
That's what I'm saying. AB 00 is not rounded off, right?
Okay.
AB 00 is max term. What is max term expression? A plus B.
Yes.
0. 2 are
Yes, sir,
uncommon.
yes, sir.
A plus B. That's it.
Okay.
Writing SOP minimizing, getting A plus B.
Okay.
Or writing POS directly.
Okay, sir. Okay. In that way. Thank you, sir.
Thank you. Any more doubts? Bhaskar.
హలో,
Bhaskar.
గుడ్ ఈవినింగ్ సార్.
Very good evening, Bhaskar. Tell me.
సార్, ఇది డిమార్క్స్ ముందు ఒక ప్రాబ్లం ఇచ్చారు కదా సార్.
Number of NAND gates అన్నా?
అవును సార్.
ఏమైంది
అందులో? ఇప్పుడు I0 ఓకే సార్, ఇప్పుడు నెక్స్ట్ I1 ఉంది కదా సార్.
అవును.
I1 కి ఇప్పుడు ఈ సర్క్యూట్ నుంచి
చేస్తున్నట్టవా?
అంటే సపరేట్ గా చేస్తే ఇంకా ఎక్కువ అవుతాయి కదా సార్ మరి.
కానీ మినిమం అది అడిగింది.
అంటే ఇక ఇట్లే చేయాలని మనకు ఎట్లా తెలుస్తుంది సార్? ఇక
డిజిటల్ లాజిక్ సబ్జెక్టే అలాంటిది నాన్న. ఇలాగే వెళ్ళాలి అని ఉండదు. లాజికల్ గా ఎలా పాసిబిలిటీ అలా చేయాలంతే. ఇలాగే ఎందుకు వెళ్ళాలి అంటే మనకు కొన్ని సబ్జెక్ట్స్ ఉంటాయి, అంటే సబ్జెక్ట్స్ అలా కాదు, కొన్ని మెథడ్స్ ఉంటాయి, అలాగే ఫాలో అవ్వాలి. అలాంటిది డిజిటల్లో ఉండదు.
ఓకే సార్.
గుర్తుంచుకో, ఎప్పటికి కూడా డిజిటల్ అనేది లాజికల్ సబ్జెక్ట్.
ఓకే సార్.
ఈ లాజికల్ సబ్జెక్ట్ ఇలాగే వెళ్ళాలి, ఈ ప్రొసెసర్లని వెళ్ళాలి, ఇలాగే ఇంప్లిమెంట్ చేయాలని మాత్రం లేదు. లాజికల్ గా ఎంత పాసిబిలిటీ అంత చేయొచ్చు.
ఓకే సార్.
ఎప్పుడు కూడా డిజిటల్లో ఫార్ములాస్ ఎక్స్పెక్ట్ చేయకు ప్లీజ్.
ఓకే సార్. అంటే వేరే దానికి ఇక వేరే సర్క్యూట్లు ఇస్తే చాలా వస్తుంది కదా సార్.
లాజిక్ అప్లై అవుతుంది, అందుకే దీన్ని డిజిటల్ అన్నారు. అది ఈజీ అన్నారు ఎప్పుడు ఏమీ చెప్పకపోతే. అంతేనా?
ఓకే.
టెన్షన్ తీసుకోకండి, ఏం కాదు. నిదానంగా లాజిక్ డెవలప్ అవుతుంది. అంటే ఒక్కసారి అడిక్ట్ అయ్యారనుకోండి, మిగతా సబ్జెక్ట్ అసలు నచ్చవు.
ఓకే సార్.
ఒక్కసారి కనుక ఈ సబ్జెక్ట్ కనుక అర్థం అవడం మొదలు పెట్టిందా, ఎలా ఉంటుందంటే ఒక యాప్ట్యూడ్ నేర్చుకున్నట్టుగా ఉంటుంది. యాప్టీ చేసుకున్నప్పుడు ఎలాగా అంటే ఎంజాయ్మెంట్ అనిపిస్తుందో అలా అనిపిస్తుంది.
ఓకే సార్.
ఎంజాయ్ చేయండి అంతే, చేయడం ప్రాక్టీస్ చేయండి అంతే.
ఓకే సార్.
Yes.
Good evening, sir.
Good evening, Manisha. Tell me.
Sir, in previous class you said BCD binary to gray code. No,
Yeah,
sir.
that I think you have message, right?
No,
Minimal
sir. No,
expression. Minimal expression you are asking.
no, sir. Not that.
Okay.
Sir, in previous class you said like conversion of binary to gray code, na, sir.
Okay.
Sir, in that we can convert that like consider binary as BCD to gray code.
No, no. Don't say BCD there. Just binary. It's
Yes,
not
sir.
BCD.
Like, is there anything like BCD to gray code? Like that I am asking, sir.
BCD to first we need to convert to binary.
Yes, sir. Sir, binary and BCD are
Or
like,
not.
yes, sir. But just like BCD is of 4 bits and binary is of
Representation of each and every digit.
yes, sir. Sir, like we can't use gray code as a codes like you said, na, sir. Access 3, 8421, 84 minus 2 minus 1, like that. We can't consider gray as
Are you asking about XS3 or gray?
gray, sir.
Gray is cyclic code.
Like I'm asking gray and
So
access
we
3.
cannot use to represent digits. No,
Yes, sir.
we cannot use that gray codes for representing decimal digits. No.
Okay.
Right.
Sir,
That,
now in this question only, sir, like in these examples, we have for every column we have one round, na, sir. If there is no round, then we
Zero.
have to consider this to be 0, na, sir.
For implementing 0, we don't need logic gates, right?
Yes, sir.
For implementing
Sir,
1 also, we don't need logic gates.
yes, sir.
Right.
Sir, I have another question. Previous, you gave a question after giving a break, na, sir. Before giving a break.
Okay. What was the question?
Sir, I don't know. It's same number.
Just implement before the break means 2 questions like this, right?
Sir, this one, sir, the previous one. Yeah,
This
this
one.
one.
Yes.
Yes. Sir, here you said to frame a Karnaugh map, no, sir?
If it is asked to get minimal expression, we go with Karnaugh map, right?
Yes, sir.
It is not asked minimal expression. Already expression is given.
Yes, sir.
This expression is given, function is given. We need to implement using 4:1 multiplexer. In that, I have chosen different possibilities. Some possibilities are concerned. You can go with the remaining possibilities also.
Sir, not this one, sir. Another one.
Before break means
You
these
said
2.
you gave 2 questions, na, sir. In that, we have to reduce them using Karnaugh map.
Is this the question? Is right? This I did not do minimal expression.
Yes, sir. Yes, sir. This one.
Yes.
Only. Yeah.
Right.
Sir, like it's a bit confusion, like a prime implicants to consider prime implicants, sir. Like I'm getting.
Please, can you help me with the numbers I'm writing right now?
Yes, sir.
Please help me with the numbers.
1, 2.
Just. Yes.
1, 2.
2.
4.
4.
6, 7.
6, 7.
8, 9.
8, 9.
10, 11.
10, 11.
12, 14, 15.
12, 14, 15. Right.
Yes,
Whatever.
sir. Sir, for this I got essential prime implicants to be 4 and prime implicants to be 7. Is this correct, sir?
Let me check. This is essential. This is essential. Right?
Yes, sir.
This is also essential. And here we are getting 1. 1.
Sir, another cube also.
Cube quad, right?
Yes, sir. Quad.
In these, how many are essential you're asking?
4.
1, 2, 3, 4. Yes, 4 is.
Sir, prime implicants are 7.
Count it. 1, 2, 3, 4, 5, 6, 7. Yes.
Okay. Thank you, sir.
Right. Sanjeev RP.
Hello.
Yes, Sanjeev.
Sir, in 11 of states, sir.
Okay, going to that. Yes.
Sir, explain this answer.
So, this directly you want me to explain or all? This one how we are implementing, right?
Before this one, sir. You explained three different ways, no, sir.
Okay. When it is shorting all the inputs or select lines. S1,
Okay,
S1 connected to yes.
Oh, okay, sir.
Then what we get possibility when S equal to 0, S1, S0 is 0, 0. S equal to 0, I naught, right? When S equals to 1, S1, S0 is what?
0.
S equals to 1, S1, S0 is what? 1, 1. That means this is the output. There it must be I1. Remaining, I use 0 or 1, not a problem.
Oh, okay, sir.
Right?
Okay, sir.
In this
Thank
case,
you.
S equal to 0, we are getting 1, 0. That means 2. In this case, S equals to 1 means 1, 1. It is 3.
Okay, sir. I got it, sir.
Right.
Okay, thank you, sir.
Thank you. Okay, then, if you don't have any doubts, see you tomorrow.